Yes, perfectly. Thank you.
Okay, good. So, good morning, everybody. My name is Ari Pottu. I come from the University of Oulu, and I'm a professor on dependable wireless communications. And at the same time, I'm the vice director of this 6G flagship program that we are running from University of Oulu. Now, the job that I was given by Jari was to talk a little bit about 6G, what it might mean, what it's not, and I have prepared a slide set for you. So let's start. First of all, there is a certain kind of timeline for 5G. 5G release 15 was released 2018, and release 16 is coming out approximately now. And there are future releases for 5G coming up every 18 months, give or take. Obviously, this COVID-19 situation has slowed down also the standardization process, but still 5G continues to evolve over the next 5 to 10 years, definitely. And we do not know what are the features that will be eventually in 5G. We already know the release 15, which is targeting the enhanced mobile broadband, so basically 4G with steroids. Release 16 is targeting this ultra reliable, low latency communication capabilities of 5G, thus bringing in lower latencies and more reliability. And release 17 is targeting then this massive machine type communications. But for us in the research field, and this by no means is intended to steal the thunder from 5G. We all know that 5G is being deployed globally. Some countries are further ahead than others. Some have not even started yet. So the 5G deployment is just about to start. So therefore, we do not wish to steal the thunder from 5G, but we already recognize the fact that it takes a decade to develop the necessary technology enablers for the next generation mobile communication systems. And we need to start now in order to have something ready by the 2030s. What is 6G? Well, it's many things, and nobody knows yet what are all the things that are there. So we do not know yet exactly what 6G is. We do know some of the basic technology enablers that should be there for the 6G era in 2030s, but we do not yet know how these different enablers will be deployed in a system-wide design. Few words about this flagship program. First of all, it's a national flagship awarded by the Academy of Finland, and it's targeting years 2018. So we have started already almost 3 years ago, and we will still continue 5 more years until the end of 2026. The total ecosystemic volume that we expect to reach in this program is somewhere around 250 million euros. This flagship funding coming from Academy of Finland represents about 10% of this funding. Rest comes from the university itself, and a huge number of different projects that are run with the 6G flavor. Then when we start to look at the program content, what type of research activities do we have inside the research or the flagship program? First of all, we expect to see that the wireless connectivity is going to be, that's when I come from University of Oulu and Center for Wireless Communications, which basically tells us that the wireless connectivity is something that we are heavily concentrating on. And what do we aspire as terms of, for instance, data rate is about 1 terabit per second to be the maximum capacity of the 6G system. So 1,000 gigabits per second. And then, as we have already witnessed, that this ultra reliable low latency communications of 5G will introduce millisecond latencies end to end. We have already concluded that this is not sufficient, that we need to take this low latency communications further. So that is the second area of study in the wireless connectivity. How low can you go in terms of latency to allow automatic industrial processes, for instance, self-driving vehicles and such autonomous processes and platforms. So this is one thing. One is high, even go higher in the data rate, and the second one is going down on the latency. And not just on the latency, we also need understanding of the timing of the system, so that some industrial processes require exact timing, which means that the jitter when a message arrives should be also controlled down to microsecond level. And that introduces this time sensitive networking and global awareness of time. And that is sometimes tough bill for wireless systems, since we all know that propagation channel is in wireless communication such that you can, sometimes it's hard to predict when a message will arrive, but mechanisms are being developed how to do that. Now, if we talk about terabit per second, that means that we need a huge bandwidth, right? Now, that brings us directly to the second research area of the flagship, devices and circuits. Since we now think that we need up to 1 gigahertz bandwidth for our signals, we can manage maybe with tens of gigahertz bandwidths, but regardless, such bandwidths are not anymore available at the lower frequencies. Obviously, 6G will entail solutions for lower frequencies, but the hard part that we are currently tackling is going to sub-terahertz communications. And as it appears, the current semiconductor materials cannot provide sufficient power in an effective manner when we go beyond 100 gigahertz center frequency. Therefore, we need to look at new terahertz communication materials, what type of semiconductors are needed there. And the second thing that rather directly arrives from this fact is the fact that we need to figure out how to make the circuit designs in this terahertz region, since materials are new, and hence we need new processes to make the circuits, semiconductor processes, and new design principles. So devices and circuits, when we go to terahertz communication, is one of the key research areas of the flagship. Third one is distributed computing, or you could claim it to be mobile edge intelligence. And this means that by introducing machine learning, or in more generic terms, artificial intelligence algorithms into your network, close to the users, not anymore into the centralized cloud, but close to the users, you can optimize really fast either applications or also the network functioning. How does the network function? So that can be also be optimized by the use of machine learning. And here we also start to see new type of user devices or mechanisms to consume data, such as this augmented reality, virtual reality, and such things. Eventually, it may lead to a situation when these smartphones of today start to gradually vanish, and we start to see new type of user interfaces into the data pool. And the third area is the services and applications. As I mentioned, one of the areas is how do we see the future services and how do we consume the data. But on the other hand, it also means disruptive value networks. As one can assume that when we go to the higher frequencies, link distances will be shorter, Obviously, it can be alleviated by using a huge number of antennas and such to gain in the propagation loss in such a way that we can go up to maybe hundreds of meters of link distances. However, that always is a costly thing to do, and therefore most of the 6G high frequency networks are indoor networks, and that means that there might be room for new value networks. The flagship has threefold goal to support companies in finalization of the 5G standard. And we have a 5G test network facility in Oulu. Similarly, there is one in Aalto, one in Tampere, in many places in Finnish universities to support co-creation in terms of how 5G can be used in for instance, industry, or how the 5G could be used in self-driving vehicles, drones, for instance, or shopping malls, hospitals, so on and so forth. The second area, which is the more blue sky and exactly the focal point of the 6G flagship, is the fundamental technology components to enable 6G systems. So we are doing quite a lot of long-term research to find out what are the technology components to be used and how to fine-tune them to fit the 6G bill. And obviously, we wish to find out mechanisms and offer solutions how to make the digital society inclusive digital society, so that we can start to have easy to use and services that are available everywhere in 5G and 6G era. Well, vision is mission, but what it states is that it's data driven. So it means that the data is in the center of it all, and it's near instant and it's unlimited wireless connectivity. So basically what I was just talking about, AI, high data rate, and how to use the data. Some of the numbers of the first 3 years of the flagship operation, we have either part-time or full-time people working for this flagship. It's now 420 people around. 55 doctoral degrees over the first 3 years. As I mentioned, a large number of different research projects are running on top of the Academy of Finland funding, 267 projects over the 3-year period. A lot of publications, and then I will briefly touch the 6G white paper later on in the presentation. And we have written 13 white papers which have received, at the last time we checked, 660,000 downloads. So basically this means that this flagship, as it was the first 6G research program is in the world, is influencing the direction of 6G globally. And for instance, affecting research, development and innovation agendas. For instance, EU Horizon Europe program has adopted many of the principles and the ideas from these white papers. And to mention one more thing in terms of collaboration, we have started this HEXA-X Horizon 2020, last of the Horizon 2020 projects, which is deemed to be the first European project to define the technology components in 6G in terms of European understanding. We have been involved since 3G period in these European defining projects. For instance, 3G was defined by FRAMES project, 4G by WINNER projects, 5G was defined as FP7 METIS project, and now this Horizon 2020 HEXA-X projects is deemed to be the one that provides the European view of 6G building blocks. Now, well, there are challenges. I mostly said what is in this slide already, but I will skip and take a look at these. Up to 4G, the human and the needs of the human were in the focal point of mobile cellular communication. We use voice, we download videos, and it's all about human consumption. So human consumption of data. 5G and 6G era obviously is targeting not only humans, but including machines, processes, and autonomous things. And that means that the vertical industries, may it be banking, energy sector, in manufacturing industry, sports, you name it, those are driving the development in the future. That means that network architectures should be fitted to, let's say, fulfill the needs of these verticals. And there is the second trend due to the fact of these lower link distances and indoor networks that the network architectures will change. New value chains appear. For instance, we have been pushing this local operator paradigm already since 2015. And for instance, this 5G test network that we have here in Oulu and similarly what is there in Aalto is basically a local operator system. So basically, we are an operator, but only locally. So that is something that will appear in 6G, already in 5G, but also in 6G era. One of the things is that more than 3.5 billion people are still unconnected, no connection to the internet whatsoever. And that is one of the key, let's say, targets for 6G, connecting the last billions. And that is basically a versatile problem. It includes the satellite and non-terrestrial component, but also local community networks and many different solutions that could offer these internet services to all. So basically, digital inclusion is at the heart of the development of 6G. Autonomous wireless systems, as I mentioned, these latencies need to be still pushed down so that we humans are rather slow. I mean, our response times are in few milliseconds if we talk about touch, tactile internet, and other senses are even slower. So machines, on the other hand, can operate in the microsecond and even nanosecond domain. So we need to develop these systems using these new capabilities provided by these wireless connectivities. And as I mentioned, we are in the brink of requiring new materials, new circuit designs, and new factorization processes for semiconductor circuits. So technology leap is required. We published in 2019 the world's first white paper, and it's been downloaded already, I don't know, 350,000 times, and it gives a lot of research questions for the academic community. What type of research questions should be answered when developing 6G? And it states that the research vision is based on 3 cornerstones. Really bringing in the data to the heart of the system. Second thing is that we need to include sustainability, United Nations Sustainable Development Goals as heart of the key value and key performance indicators when developing a 6G system. And then it's all about value networks changing. So numerous business and societal players together create the new 6G infrastructure products and services. Now, last summer, we provided 12 new white papers. And if you are interested in more detailed, let's say, discussion and description of the what type of components, elements, what type of business models, what are the drivers of 6G, how to use edge intelligence in 6G, what are the broadband connectivity solutions for 6G, and so on and so forth. What are the RF parts of 6G? So these white papers prepared as a collaborative action within a community of 250 participants from more than 100 organizations, describe in more detail. I will have few examples of the solutions provided by these, or suggestions provided by these white papers in the slides, which are still coming up. But if you are a 6G enthusiast, I propose you to go either Jultika Oulu or 6gchannel.com, and you can find these white papers there. And if you wish to study, please take a look at those. So I already mentioned that the data consumption and new device forms will appear. Smartphones are likely to be replaced by some kind of XR experience, maybe even wearable systems. And displays in cars, for instance, can be embedded in the glasses of the windscreen and the side glasses of a car, and so on and so forth. So basically what we start to see is that the environment that we live in is providing us the human machine interfaces, or the displays that we are foreseeing. Obviously that this does not happen today, tomorrow, not in 2 years, not maybe even in 5 years, but in 10, 15, 20 years, we start to see these kind of things happening. I already discussed this local operator paradigm, and it mainly comes from the fact that transition to higher frequencies and the increasing role of indoor networks will boost the requirements for network sharing in cities, indoor spaces, and drive this local operator paradigm. For instance, a factory, for instance, Nokia factory making base stations, would like to have really secure, really low latency network within their factory so that they can control the environment down to the last microsecond, so that they can pull everything out of the resources in the factory. And they can put, for instance, let's take, for instance, robots. Most of the things are, well, at least, for instance, Nokia Oulu factory, all the base stations are already assembled by robots. Humans are only in a supervisory role. So they are looking on top of that everything goes as is supposed. So if we take, for instance, robots and take the brains out of the robots themselves and bring it to edge computing server, which is at the factory, then you can have collaborative robotics algorithms running in the edge cloud, and makes your assembly lines after that really easily changeable. So if there is some product change, you don't have to go into every robot and basically reprogram them or whatever they do, but you can only change the algorithm within the edge computer, and then again your robots will collaborate in a new fashion. Just an example. Another one is quality control. For instance, you have cameras which are looking at the printed circuit boards, and they can immediately see whether there is something wrong by using machine learning and video analytics. So a lot of these kind of things which are local and which are required at the facility will drive this change. Stakeholder roles will change. One of them is this micro operator, but there will be other type of operators and stakeholders. For instance, security providers, data brokers, different kind of context will appear into the network. But most of the players already exist. They may just change their focus a little bit, but new ones also will appear. Now, if we take a look at the initial key performance indicators, KPIs for the 6G, this is what is now available, and these are even being changed a little bit since this white paper was developed where these numbers are. So up to terabit per second peak data rates, 100 microsecond radio latency, so it means redesign of the frame structures. For machine type small scale devices, 20 years battery life. 100 devices per cubic meter, 100 radios per cubic meter, so the density should be high. I mean, where would you see this? Well, not everywhere, but for instance, a car could be an environment where everything is operated, every switch and every bolt, everything is controlled and operated by a small radio. There's a sensor, there's an actuator. You could see 100 devices per cubic meter. The traffic increase in the networks is approximated to be 10,000-fold, so 4 orders of magnitude more traffic. The link budget needs to be plus 40 dB in some applications, for instance, agriculture, where the link distances might be really, really huge. And then this extreme ultra reliability. Nowadays, people talk about 9 nines. So 99 point and then 7 nines. So 1 in 10 million outage. So 1 message out of 10 million is allowed to go waste. And that is, if you divide that into time, it's and think about link down times, it boils down to seconds per year. The energy efficiency is key. I mean, ICT systems already nowadays consume huge amount of energy. How to make energy efficiency one of the key targets is a good question. Smaller link distances and renewable energy generation might be some of the solutions, but also we need to take a look at the architectures and how those support energy consumption reduction. And the positioning, here we have 10 centimeters indoor. However, people are already talking about less sub-centimeter positioning accuracy indoors, and outdoors, give or take 10 centimeters. So these kind of generic 6G targets are presented currently in different fora. Okay, I mentioned this already, that there will be new, for instance, new materials, indium phosphide. It already exists as a material, but how to make that kind of semiconductor material perform very efficiently? How do you make circuits on that, and so on and so forth? And there are other interesting, for instance, there have been some developments, for instance, building lens antennas out of cellulose. Go figure. Now, the wildest guys in 6G, for instance, Nokia is promoting an idea. So when you have a radio link, you have a transceiver, well, let's say transmitter and receiver, so basically 2 transceivers. And these transceivers, one might be base station, one might be some kind of a user device, maybe augmented reality device, maybe car, maybe something else, that these transmitters and receivers, using artificial intelligence or machine learning, decide what is the best way to transmit data. So what is the air interface solution for that particular application and environment? Will it happen? in some degree, definitely. Whether it will be fully automatic, we'll see. We shall see. New grant-free access methods are critical. I mean, we start to have these massive machine-type communication networks, 100 devices per cubic meter. We cannot anymore assume that we have scheduled transmission of all the data. We need to have some kind of grant-free access so that you don't have to use huge amount of bandwidth for control resources. Since many of these machine-type communications only occur seldomly, but on the average, they would consume huge amount of the control plane capabilities. Signal shaping. What about analog modulation technologies in 6G? And one of the key issues we always hear in discussions is the security. We can build security also in the transmission path of the physical layer by using either coding or noise-like signals and things like this. 6G networking, this is not really my area, but anyway, this again targets the privacy, trust, and it has been proposed that instead of IP address, devices will be given IDs, which are basically non-fakeable, and basically with 100% identifies the device, and if it's malicious, you can then discard it. So it cannot anymore connect to the network. So we can somehow figure out ways how to get past this spoofing and cyber problems. Then what will happen is that we start to see the usage of this 6G signal, not only for communications, but also for sensing and imaging. Now, in high-end 6G devices, we may have in the beginning 1,000 antennas, 10,000 antennas. Some people talk about already 1 million antennas. Since we go high in the frequency, the lambda per 2, so basically the antenna separation becomes so small that you can pack in an area of 5 by 5 huge number of antennas. And it starts to resemble the CCDs of your cameras, operating on radio frequencies rather than visible light. But hey, what it is, basically it's a camera. So radio frequency cameras. So imaging using radio frequencies is becoming integral part of 6G systems. And it can be used for sensing, for instance, radar type applications, and even looking through, for instance, smoke for firefighters, for instance, and so on and so forth. So a lot of new things happening. Just picked few of those, not really have time to go through many of these. But then a couple of words about this test networking and the need for experimental environment in the future. The networks are becoming so complex that it's hard to do full-fledged analysis on papers or with simulations. And you need to start to have these test network to be able to test new application services really fast and in a realistic environment. Few words about our test network at the University of Oulu. You can see here a huge number of devices, different frequencies. We have technologies, LTE, narrowband IoT, LTE-M, ultra-wideband, Bluetooth, 5G, LoRa. Most of the air interface technologies are integrated into this environment. And what is the status of the environment? Well, it's a smart campus local operator. And we are an operator, similarly to ELISA or for instance, DNA or Telia. So only operating in certain regions locally. One of the interesting things was that we helped Nokia in the development of a millimeter wave base station. And this was demoed in EU Korea project by Horizon 2020 in the 2018 Winter Olympic Games, so that our 5G TN was connected to a counterpart owned by a research institute ETRI in the Olympic village, and then we were exchanging information and, for instance, showing the Aurora Borealis for the Korean people, since we know that Asians quite often like Aurora. So what is a test network? It's a co-creation platform. So there might be a company which is looking for applications or digital services, and they want to develop and try it out in a real environment. It could be, for instance, companies like Keysight, which are developing measurement equipment, and they wish to start to use our environment to test, okay, what type of measurement devices in the future are required. We have done millions of integrations. Well, million is quite a large number, but many integrations of 5G devices, different platforms, may they be drones, forklifts, cars, excavators, and try to make them remote controllable. That's something that we've done quite a lot. Even harbor cranes. Digital twins have been developed, for instance, for Oulu Harbor, so that you can see in real time the data which is generated within the harbor, and in its 3D model you can see who's moving, where, why, so on and so forth. So it's a co-creation platform, and since we are now in the 5G era, obviously we only have some, let's say, really proof of concept or prototype 6G devices available at the moment. But as time evolves, we wish to change this 5G test network to 6G test network. Here you can see your typical architecture of a mobile cellular system. So you have in the center of the picture, you have the core. Now we have both the 4G core, the enhanced packet core or EPC, but we also have the 5G standalone core to support 5G services in a standalone mode. Obviously, this 4G core is used for the 4G and 5G networks in non-standalone mode. Then we have these edge computers where you can bring in the services or the network optimization tools so that you can take a look at your network performance and try to optimize it, or offer a service right at the edge of the network, offer knowledge for the users right at the edge of the networks, and so on and so forth. And these test networks are connected to for instance, to Tampere and Aalto and VTT networks. So we are basically a nationwide system nowadays, and these are used in different sites and also in tests between the sites for developing new type of solutions and services. Now, yet another reason why bother with an experimental test network. Well, answer is versatility of vertical requirements. We already discussed these verticals. If we take a look at, for instance, industry enhanced URLLC, you can see that the latency requirement, for instance, is 100 microseconds, and jitter control 1 microsecond. Then again, if you take, for instance, eHealth, higher data rate, smaller latency requirements, jitter control, fine, lower densities, and so on and so forth. So how do we satisfy the needs of these different verticals? This basically says that one size fits all networking solution in 6G time isn't sufficient anymore, but you need a lot of flexibility in the system design so that you can basically allow for these local micro operators appear and allow them to be, let's say, vertical specific service provider. So there might be a operator which comes into the play, and it could be a global operator offering, for instance, energy utilities, networking services in such a way that it's optimized for energy network usage. Similarly for agribusiness or self-driving vehicles, so on and so forth. So how do we facilitate service pool and avoid technology pools? This was one of the mistakes of 5G. ICT guys develop a technology, try to push it into the vertical. When the real need might not be served, and therefore we need to figure out with the vertical players what are the service needs, use cases, and introduce this service pool and avoid the technology push. Yet another slide on the same topic, figuring out this local operator paradigm and how to do it in real fashion, in real world is an interesting question. For instance, how do we do spectrum regulation in the future? Can we devise algorithms and methods to, let's say, give local frequency licenses on the fly, given the traffic needs, given whatever is happening in the localities, so that whenever there is a service need and there's a service provider that can negotiate locally their frequency licenses, for instance. And this is something that you cannot emphasize enough. These United Nations Sustainable Development Goal has been introduced by us to be really taken into consideration in 6G network design. And we have a strong belief that we can affect many of these SDGs through ICT systems when deployed in such a fashion that they are taking into account the need to improve on these different SDGs. It might be related to capacity, it might be related to coverage, it might be related to digital inclusion. But anyways, this is something that we need to bear in mind when we are developing 6G systems. Well, this is just to say that in Horizon 2020, the European Commission invested in phase 3 of the 5G programs 190 million euros to build in the Europe these test facilities. Finland is obviously one of those. And now there's a process ongoing to build the next generation pan-European ICT testing facility. And currently what we have is 15 countries have submitted a proposal to ESFRI, which is a research infrastructure body of the European Union. And one example you might know is this CERN, this nuclear research facility in Switzerland. So we wish to be included also in the ESFRI together with 15 European member states and the partners within those countries, so that we really would have a good pan-European platform. Oh, and then marketing slide. We are going to organize the PIMRC 2021, basically in Helsinki, but we decided still, even though the COVID-19 situation is improving, to go for fully virtual representation. And anyways, this happens between 13 to 16 of September this year. So that if you are available, somehow wish to join, please bear this one in mind. And I believe I have consumed my 45 minutes. And I thank you and invite any questions, should there be any. Okay. I believe there are no questions.
If there's some questions to Professor, please type them in the chat. Oh, we have one. If you can see the chat.
Okay.
It's
There
good.
is one. What type of intelligent services have you tested so far? Basically, intelligent service could be also a MIMO antenna, right? Distributed MIMO antenna. That kind of antennas we have been testing. What comes to these intelligent smart surfaces, we haven't yet built any, but obviously these large-scale MIMO things have been tested, but not really this when they are falling under this LIS framework. Those we have not yet tested at all, but it's on the map. And then there is a question: when is it realistic to see the first 6G test networks? My guess is so that they are devices beyond proof of concept devices, somewhere around 2026. And why would I say this? Well, South Korea is very aggressive. They have already also programs running in 6G, and they are claiming that the first 6G test networks or local networks will appear in 2026. And I do believe them. They typically, Koreans are such that when they are given a target, they work relentlessly and make things happen. So why not? When it comes to proof of concept devices, we already have something on 252 gigahertz devices capable of transmitting close to 100 gigabit per second. Unfortunately, we burned the antenna. We are redesigning the antenna again. But yeah. Tubes, good old tubes for semiconductors. You mean the vacuum tubes? Well, the problem is obviously the frequency. I mean, how can you go with the vacuum tubes to terahertz, sub-terahertz bandwidth? So that's basically one of the problems. Obviously, they are very good in many applications. And for instance, the US guys, US Air Force was really, let's say, shocked when they shut down some years back, or somebody shut down a Soviet fighter which was using tube technology. And then they realized, okay, this is this electromagnetic pulse resilient way to build things. But the problem obviously is then the frequencies. Then there's a question, are there any commercial models of millimeter wave network client devices? We have already millimeter wave base stations installed. Well, they are going to be installed within the next 2 weeks. So we have ordered them from Nokia and we have those in place in a few weeks. As for the user devices, we are checking currently, and one which we found was 20,000 euros. So probably will buy one for experimental reasons, but client devices takes perhaps half a year in millimeter wave networks to appear. What type of interfaces? That is a very good question. Nokia already, together with Telia, using 2 millimeter wave base station, transmitted 8 gigabit per second data rate in Nokia campus at Espoo. What type of interface should be used? That's a very good question. I mean, if you go to user devices, I don't remember the USB, the latest version of USB standard, how much it can convey data, but probably not 8 gigabit per second. So they are using this enhanced CPRI in base stations, I believe, which basically is something that probably you wouldn't see in the client devices. But anyways, that is a very good question. I have no answer for that. But as for the client devices, maybe 1 year, millimeter wave networks are already there. Okay, I believe we have consumed our time, and I thank you all for joining this lecture and this discussion, and hope you have very enjoyable remaining time on the 5G summer school. Thank you very much, and let's see if we pump up to each other at some event at any time in the future. Thank you very much, and goodbye.
Thank you very much for your very thought-provoking presentation, Professor. It's so great to hear a step beyond the 5G when the projects that we're presenting today are all about 5G, how to utilize 5G, how to apply it in real-life context. So now to see beyond what to expect, how to actually imply that foresight into the solutions also at this point. So okay. Thank you very much.
No worries. Thank you. Bye-bye.
2, 3. Good afternoon and welcome to the final pitches. We will start soon, and first up we have the short intro. No, actually, we have the Konecranes group number 1. So please prepare your pitch and start whenever you're ready.
Okay, so welcome each and every one of you. We are Konecranes group number 1, and our presentation is about smart factories. So let's jump right into it. So agenda: first, introduction to problem, then usability, then technical solution, then advantages and disadvantages, and finally conclusion. So, introduction to problem. So, Konecranes is a world-leading group of 15 business, and 5G is a great way to make cranes and whole factories more efficient. So, but in order to do that, we need to understand how to use and how to share the resources among the entities across the ecosystem using 5G. Okay, next slide.
Okay, I will tell you more about the solution. So how we are going to solve these problems. When we get more information, it enables a high level of automation and improved communication and better optimization in the factory, as well as ultimately improved decision making. First, the scheduling of cranes and other equipments, so cranes in the right place at the right time. In addition, we are also more aware of the work environment and the locations of different machines and equipment. Second, this makes it possible to reduce unnecessary processes. Third, different wireless sensor can collect information about, for example, different loads, containers, and workpieces without fixed wires. Better visibility of unaccepted obstacles can also be achieved. And fourth, as a result, better support can be achieved for autonomous robots, which are practically our solution. Okay, so our solution is autonomous robots. Robots use 3D scanners, machine learning, video streaming, remote control, and web interfaces. We will tell you more about the technical solution later. But robots have practically at least 2 concrete application or use cases. The first is mobile surveillance. For example, remote controlled robots allow better video streaming from difficult places. Robots can also monitor critical loads during installation work. That is, for example, important distances or other parameters. Robots can also monitor various critical production lines and their disturbances and move to required locations. Robots can also monitor different workplaces and communicate them continuously to other workplaces so that resources can be organized efficiently. And because robots can have 3D scanners and 316 cameras, they can map places and detect hidden objects or corners, for example. Okay, the second use case is mobile assistant. For example, robots can work in places that are dangerous or inaccessible to humans. Robots can also handle various loads and perform installation work that requires special precision. Robots can also help with various disturbances on production lines, for example, by moving disruptive parts away from production line. Robots can also assist in installation work, such as moving heavy loads during installation, holding various installation tools or accessories, and monitoring various critical distances and other parameters. Okay, and next Rona will talk more about technical solution.
Okay, so our technical solution is based on merging the 5G core with some automated functions. So high-level automation, managing easier the networking part. Today in the morning was mentioned in the 6G talk by Professor Ari Poti. Because this is a software-defined network, it's easier to merge automation in the network management. Of course, millimeter wave is really important because this deployment is in a campus area or local area, in a room or a big factory. Then, as I mentioned, the automation of the allocated slices, network slices or network distribution. This is more related to transport, should be related to high-level automation. Basically, what we envision is slice spectrum, millimeter wave network, mid-band network in a campus, and objects in the plant floor just reporting by exception. So if they say they are there, then the automation and communication system detect them, and then everybody else can see the information, of course, filtered by resource access. Is Anne here? Well, it seems like Anne is not available, so I will continue because time is really short for us now. Basically, these robots work right now with Wi-Fi, but we expect them to work with 5G. And basically, they have inside a CPU with Linux and some sensors then connected to that CPU, and the information is going out to Wi-Fi. But that's not enough for remote control. So the remote control part is the key kind of reason why to put 5G there. So there are some advantages related to increase the productivity and reducing risk, then optimizing shared resources as the main solution for the main problem, because the robots will help to kind of balance the workload and facilitate the kind of sensing of hidden areas. And the database applications will base their operation on the data collected by the robots. Of course, there are disadvantages. Still, the price of the clients is big. Wireless is considered secure. It's not so secure and vulnerable by commercial clients sometimes. But now that perspective is changing, or that kind of idea is changing, and the technology rollout process is taking still some time. So it's not possible to have it probably this year, maybe next year.
Okay, as a conclusion, I'd say that 5G provides ways to make these smart factories and robots. Okay, yeah, next slide. Here is our bit of information of our team. If you have any questions, please feel free to ask, and we'll try to answer them as well as we can. Thank you.
Okay, that's all our presentation. I think not sure if we have still some minutes for questions.
A little technical problem. We are fixing it. Oh yes, now the little technical problem is fixed. So thank you for your well-prepared pitch. Do we have the challenge owners here? If you have any quick comments for the group, so you can please share them.
Hello, this is Juhani Kerovuori from Konecranes. Thanks for presenting your ideas, and you have had a good idea to utilize the robots as a part of the industrial ecosystem that could be formed by when the 5G will be taken into use. Like the idea was quite good and fresh, but like what was somehow a little missing? Like what is the thing that the ecosystem can benefit when the robot is there and sharing the data? But overall, good job, and I'm happy about your work. Thank you.
Thank you. Well, we can tell the benefits from the solution can be summarized as easier and adaptable ways to get data. So usually when you have fixed cameras or fixed sensors, cables are way cheaper than 5G and work still technically probably better. So the implementation of mobile robots are actually systems, those are actually systems that demand some good wireless communication because the car cannot have the cable all the time together. So I think because right now artificial intelligence is demanding a lot of data. If we have sensors with wireless support that can collect that data needed for artificial intelligence, I think the automation will benefit a lot.
Thank you both. Next, we have the Konecranes group number 2. Stage is yours.
Hello everyone, can you hear me?
Hello.
Yes, we can. Can you hear me?
Yep.
Yeah, okay, great. Yes, so my name is Zui and I'm from the Konecranes Group 2. And so basically we have the same challenge with the Konecranes Group 1. And that is how different entity in one smart factory can use the same resource fairly and how the added value is to be shared among all the entities across the ecosystem. Next. And yeah, we are using, of course, we are applying our solution to the smart industry. Next. So our proposed solution will be surrounded, revolved around two main questions. First one is what is the benefits? What benefits does the introduction of 5G will bring to the industrial solutions? And the second one is why it is not already in use yet. Next. So talking about the ecosystem that we are going to build our solution on. So firstly, it will enable to solve the shared resource challenge and meet the shared objective, which is the main challenge. And we are going to apply it to the smart factory, and connected digital ecosystem. We of course will include the crane, truck, machine, sensors, wireless camera, basically everything up in the factory with the data centers and the crane portal, and all of that will collectively form an ecosystem. And technologically, the ecosystem will include the machine vision-based detection and real-time digital surveillance. Next. And yeah, talking about our proposed solution, we're gonna use the 5G wireless camera network with the machine vision and deep learning based vision to detect the stuff. And of course, all of this will be going to use in the IIoT, so industrial IoT, and the data will be aggregated on the 5G multi-access edge computing, or so-called MAC edge node, and the data can be used for the deep learning and self-optimization in the cloud, and with the potential to offer a greater improvement in the accuracy of the product detection. And the solution aims is to looking at the defects of the products and perform measurements, the tasks that have already previously done by the humans. Next. And so why 5G? The 5G will support us in many different ways. It brings higher accuracy and lower latency in the IIoT use case with ultra reliable low latency and new spectrum, higher bandwidth, higher data rate, and with beamforming technique and network slicing and greater flexibility. And even greater than that, with the 5G 3GPP and release over 16, we're gonna have the positioning accuracy below 3 millimeter. Next. And yeah, as you can see here, the 5G transformative benefits for the smart factory. And yeah, next. And the focus of our solution will gonna be on the employee safety and the sound working environment and the quality assurance. So things like machine maintenance, just-in-time inventory system. Next. And the requirement for our proposal will include the machine vision system, of course, and the high network requirement, which is upstream of bandwidth of 50 to 200 megabit per second, an end-to-end communication latency of less than 10 seconds, and reliability requirement above many number 9%. Next, and this is the upgraded existing industrial network with the wireless 5G. So as you can see here, and next.
So I'll take over from here. Thank you. I'm Venla. So next I'm going to talk about shared value, what kind of additional value our solution would bring. First of all, obviously it facilitates the exchange and the use of data between teams, which are manager, sales team, workers from the sensors by collecting meaningful data points on a cloud or offline database for tracking. This cloud could be private or it could be public as well. Obviously private is a bit more safe. We can also allow access to data at any levels, which in turn improves performance and whole production pipeline will be more efficient this way. There's also, we already kind of touched upon the MEC. So the edge intelligence also brings us some more added value from edge training, edge inference, caching. So we can analyze, train, and cache on the cloud. We can also use machine learning to improve and optimize our algorithms that we are using. And there's also the possibility to provide room for new improvements based on this data collected. The data collected helps us to understand the machine's behavior, and we can provide the best maintenance service possible and improve machines' efficiency and build strong relationship with the customers when we are collecting as much data as we can with the solution we're proposing. With the optical character recognition, which is basically text recognition, we can assist to prevent accidents and facilitate smooth production line. So basically this is, say you have a label somewhere and the labeled thing is going in a wrong place. You can recognize that with the usage of the cameras. So you can prevent accidents that otherwise would be left unseen. Also there's the obvious sensors, so you can monitor manufacturing environment. So this enables you to control the environment and avoid wear and tear in machines, or more likely you will recognize this wear and tear earlier than a human eye may be. So this will improve your quality assurance. We'll continue. So we did some pre-work on what Konecranes is already doing. So we based our solution on the fact that they already are going to deliver this 5G standalone as a private wireless network. And they mentioned one use case being the deployment of high-resolution wireless cameras to, in their case, improve load handling, safety, site security, and operational integrity. So we thought that making use of these already existing deployment of high-resolution wireless cameras, we could also add on different applications to those. This is a case of what Konecranes is already doing, the stadium from Aalto University. So, okay, we're going kind of over time, so I'll just fasten this up a little bit. This is an overview of activities at Ojama plant. which is Fujimi's plant in Japan. So they also use these kind of cameras to analyze videos. So this is about that. So they introduced 4.7 gigahertz band network, and basically they measure accurate position measurements and route control. They use AI to get better information from this. They also get instant feedback, which is something that is very useful, obviously, for safety and for quality assurance. So we're going a little bit over time. This is also an overlook of the system that they have at the Fujitsu plant. So what's the negatives of our proposed solution? Well, security, in a way that 5G obviously offers more security than many other ways, but the fact that not many people working there might be very familiar with the security aspects of 5G, because it does use a little bit different security protocols than 3G or 4G does. So maybe the lack of information in the employee base could be a problem. Also the connectivity. So if you are very rural, you might not have as good of a connection, because the 5G does get obstructions from, say, buildings, trees, towers, and these kind of things. So that could be a problem in a more rural space. Also, if you depend on the 5G too much, it could actually, decrease the safety if people trust on it too much and are not as aware of their surroundings as they were previously. This is it. Thank you. Sorry for going a little bit over time. Now, if you have any questions, please shoot them our way.
Hello, this is Juhani Kerävuori from Konecranes again. So thanks for your presentation. And, I like that you are having the concrete idea what data should be utilized and how. And as a conclusion, your presentation was quite good, and you were having a concrete idea, and and more or less there is something that we could utilize in our upcoming research programs or research work that we are doing. So thanks a lot about your work.
Thank you.
Hello, this is Timo Lundstedt from Konecranes. I would like to thank both of the groups as well. I think from our point of view, it was really nice that you both went a bit different ways here, and that really adds like innovative value for us too. And especially personally for you, Venla, I really like how you ask a lot of questions and good questions. So keep that up as well.
Thank you.
But yeah, very much thank you for both of the groups.
Yes, thank you so much.
Thank you.
Thank you so much for both groups for your well-prepared and creative solutions for the challenge. Next, we are going to move up on, excuse me, the GoodMill Systems groups. So GoodMill Systems group number 1, stage is yours. Please, you can start whenever you're ready.
Okay, good afternoon, everyone. We are the first group representing the solution for GoodMill Systems challenge. The challenge was focused upon the performance, features, and use cases for LEO constellations presented by our company, and it was also to focus the how this technology is going to develop and the possibility of using multi-channel routers with SATCOM was also in question. So Kunle is going to continue now.
Yeah, okay, thanks. I'll take it from here. Could you please make this full screen, the slide? Yeah, it would be much better in presentation view, but anyway, as Manish mentioned, that this our performance features and uses cases for LEO constellations is our main challenge in various environments. Addition to the development of this technology and mainly the possibility of using multi-channel routers with SATCOM. But before going to this, we'll briefly describe this satellite positions and their names. In fact, there are three kinds of satellite based on their positions. One is HEO, which is called high elliptical orbit. One is medium Earth orbit, which is called MEO, and that's the distance is actually from 2,000 kilometer to 35,786 kilometer above sea level. And our main discussion, which is based on LEO, is called actually low Earth orbit. It's actually some kind of satellite orbit around Earth in 1.5 to 10 hours, and an altitude of 300 to 1,600 kilometer with a beam footprint of 100 to 1,000 kilometers a second. And we are actually talking about this kind of NTN LEO satellite, which is a non-terrestrial network and low Earth orbit. About this feature of SATCOM 5G network, we'll go to the next slide. We'll go to the next slide, please.
It's on the next slide. Is it not working?
No, it's not the next slide. I mean, the slide number 3 that you are. Yes, that's slide number 3. So about the feature of SATCOM 5G network, the first thing is reliability, in the sense that SATCOM is resilient to natural disasters and other mass emergency situations that could destroy terrestrial infrastructure. It maintains service continuity despite these conditions. Also, the most remote and inaccessible parts of the world will have this kind of connectivity from the space where a terrestrial network could never reach. In addition to this, SATCOM could function as a jam breaker for a terrestrial network when the traffic is big too much and like it's really hard to handle from the ground. So I'll hand over to Jere from slide 4.
So yeah, in 5 years, this large constellation will be connecting the world with SATCOM. Based on one paper from MIT that compared 4 giant fleets, OneWeb will have more than 6,000 satellites followed by 4,000 from SpaceX. However, Amazon is expected to offer highest throughput. SpaceX is closest from us, but still Telesat maintains the highest satellite utilization of 44.3%. Despite being the farthest, it is still to be seen in the future how these constellations might enhance their service as the competition rises. But for now, this is big news for each of us. Slide 5. Latency is still an issue to the distance between Earth's surface and satellites. To add up to this complication, fading signal and interference due to different weather and atmospheric conditions and path loss are already there. And here on Earth, need for numerous space stations might propel the cost structure even higher. So Manish, continue.
Yeah, so we tried to focus on how good mill systems can benefit from these, especially with marine industry and high-speed trains, as the reliability is what satellite 5G promises. It would enhance the network capabilities in vessels and trains, allowing seamlessly high data rates in the future. And these are mostly for areas where local infrastructure is out of reach. So it could be in the middle of an ocean, a forest, or rural areas, because rescue operations, they always come like it's some kind of urgency there. So it's not only in urban areas. And this SATCOM connectivity, it applies to police, ambulances, and firefighters as well. And we're still getting familiar with this concept, but one company had the solution for this one. It has even applied the virtualizations of its network layers. And what it does is that it has combined this MF-TDMA and DVB, the second generation technology, to connect to the satellite, while the DVB link, it's one directional, and it initiates the DVB link between the hub satellites and the remote station. The TDMA, it allows communication between hub and remote stations, or the remote stations could communicate independently once the link is set up. And the interesting functions here was the virtual routing and switching functions that would slice up the satellite network as per in many virtual private networks in those remote sites. And the adaptive coding and modulation, the controller, it could specify it could control the network access in addition to the feedback from the receiver, which would kind of error correction as well. It would work with that one too. And while we're researching on our project, we came across this idea of the so-called my Wi-Fi routers for caravan vans. It could open up a new market segment for it's kind of niche market, still growing, but with the introduction of 5G, it could be something that would allow GoodMill to open new market segment. So yeah, thank you for listening, and we're open to questions.
Yes, please. Now you can present questions for GoodMill Systems Group number 1, if you have any.
Yeah, I see one question there.
Okay.
So all these constellations now, of course, they are there to provide the world with 5G technologies, and these enhancements of these technologies are still it's not yet, they haven't launched all of the fleets yet. They are gonna do we found out that they're gonna do that in 2 phases. So the first phase is just to the testing of the network, and the initial setup would be done by like hundreds of satellites, and after that they would be launching the thousands. So of course, yeah, for 5G.
Hi, this is Tobias from GoodMill. First of all, thank you a lot for your presentation and your work. It was a very, very nice pitch. I had one question at this point, which was kind of like you mentioned the, if I understood correctly, the possibility of using the satellite network as an overflow if the terrestrial network is congested. Have you calculated, or do you think that it makes it different for the overall capacity, or just for some specialist users that are then able to connect when the terrestrial network is down?
Yeah, that's a good question. Actually, it's a bottleneck breaker in the sense that when the traffic is congested with, let's say, in certain areas, then the virtualized functions, it redirect all those routes to and allocate resources for that particular part of the network from those unused parts. Let's say there could be some areas and people might get crowded at a stadium. At that point, the whole city could be not using the internet at some other parts. So in that sense, it could provide a wider bandwidth to that particular part of the city.
Okay.
Good work, group. Next up, let's move on Good Mill Systems group number 2. So please share your screen and start when you're ready.
Hello, am I audible?
Yes.
Yeah. Okay. Thank you. Hello everyone, I'm Aditya from Goodmill Systems 2. Our challenge owner is Goodmill Systems Limited. Goodmill Systems Limited is a global market leader in critical broadband connectivity for vehicles and public safety, healthcare, and security. Our challenge is to integrate. Our challenge is integration of non-terrestrial and terrestrial 5G networks for mission critical communications to serve public safety customers. Customers include police, healthcare services, autonomous vehicles, railways, maritime services, mining and construction companies. So there are Goodmill Systems have a wide range of customers. Our task is to understand the performance, features, and use cases for LEO constellations in various extreme environments. Till today, cellular communication and satellite communication are working independently, but there are many use cases if we can integrate both the networks. Most common today, the most common scenario which we can see is we have a separate satellite phone to connect to the satellites and a mobile phone, the normal mobile phone which we use daily for the cellular networks. But in future, if we can combine the same mobile phone to the satellites as well as the terrestrial cellular communications, there are a lot of use cases. For example, when we go into deep forest, or if there is any damage to the cellular networks, then we can directly connect to the satellites. The main benefits of satellite-based communication are wide coverage and ubiquity. It is very much essential when the terrestrial network is damaged. Based on their positions, non-terrestrial networks are classified into LEO satellites, MEO satellites, GEO satellites, and high altitude performance stations. High altitude performance stations are unmanned aerial stations. So these are at the range of 8 to 50 kilometers, and LEO satellites are at the range of 300 to 1500 kilometers. As we move from the surface, the latency increases. So for some cases, for the latency sensitive cases, we cannot rely on non-terrestrial networks completely.
In this picture, here is a simplified version of a networking system. Here you can see the role of a satellite network. They are used to connect, mainly used to connect the remote and rural areas, and also a few others.
Also, in this slide, we can see the ground terrestrial networks has two terminals to connect to the satellite network. One is VSAT and other is the user equipment itself. That is, the user equipment will be hybrid. It can connect to the cellular terrestrial network and to the satellite as well. For any system to be universally deployed, we need standardizations. The standardization for non-terrestrial and terrestrial networks are shown here. The different standardizations are defined according to the use cases, like 5G SAT requirements. So what are the requirements for the satellite and 5G terrestrial integration are given in the technical report 22.822, and the applicability is given in the technical report 38.811. And for maritime, it is technical report 22.819.
All the standardizations are given by 3GPP, Third Generation Partnership Project.
Many companies are now planning on 5G satellites. Here are 5 companies that have planned for the satellites. I have collected data about their satellite installations and when they are planned to be available. Some of their customers are more like military and government, and some are more like personal use. For example, the OneWeb, their system is kind of like Starlinks, so they have like satellites. Satellites connect to the roof antennas and transmit data that way. And for example, the Lynk and AST and Science, they have been able to connect directly to unmodified mobile phones. Here are the 4 main use cases for satellite connection. The first one is edge caching, multicasting and broadcasting, and also offloading data when there are traffic in the terrestrial networks. A second use case is for fixed 5G backhaul to connect rural locations that otherwise couldn't be connected with terrestrial 5G networks. Fourth use case is to connect 5G and terrestrial networks, 5G satellite on terrestrial and terrestrial satellites, to combine them for better reliability and better data transmit. And the fourth and final use case is for moving platforms such as trains, ships, and planes that otherwise couldn't be connected to terrestrial networks. We have classified the use cases into 4 categories. For mining and construction companies, for setting up remote healthcare, for emergency services, for autonomous cars updates, for railways and remote connectivity, for maritime services, and entertainment services for passengers on move, and for homes and offices.
The challenges that we face while integration of terrestrial and non-terrestrial 5G networks are latency minimization. As the satellites are situated far away from the Earth's surface, there are latency issues, and spectrum scarcity. Energy consumption due to the satellite communication is more when compared to the terrestrial networks. And also there are integration related issues like the mobile phone or the user equipment that we use today is only capable of combining to the cellular terrestrial networks, but it should be hybrid and it should also be able to connect to the satellite networks when there is no terrestrial network present. And the integrated 5G satellite must be resilient, because once the satellite is launched, we cannot fix it if there is any hardware malfunction. Of course, there can be software updates be done, but if there is any hardware issues, we cannot fix it. It's gone further. And the LEO satellites must be deployed in mega constellations, that is in the numbers of hundreds and thousands. So it costs a lot. It also it costs in the range of billions of euros. So it should guarantee the quality of experience, and it should also support the IoT or machine-to-machine communications, and it should also give high data rate videos. This slide shows the proposed system. Satellite communication is connected to the remote maritime services, airplanes for providing the onboard connectivity, and for hospitals for critical health care in case the terrestrial network fails, and for public safety police. And it is also connected to the remote industries for massive mission type communications in order to boost the Industry 4.0 and industry automation. Finally, I would like to conclude by saying that satellite communications are more expensive and has more delay, but it also gives more reliable communications. So it can be best used in combination with terrestrial networks. Thank you for giving us this opportunity and listening to us.
Thank you so much. Now, if there's any questions, please, you can show them for the group. And if there's not, we would like to hear a quick comment from the challenge owners, Good Mill Systems representatives.
Hi, so Topias here again. Thank you for the presentation, an excellent presentation. Many good points as well on this one. I guess I had sort of a semi question or thing that I would like to understand better. You had these use cases split into these 4 different categories a couple of slides back. This one, yeah. Are these sort of like these images, are they directly related to those use cases? So is this like a headline for the use cases? And can you maybe elaborate a bit here how you're thinking about this?
Yes, sir. Like here, the for mining and construction companies, they will be often they are the remote locations. So laying a fiber cable for such long distance is not feasible. So instead, we can connect it to the satellite. So one of the ground terminal is connected to the satellite, and the rest of the sub terminals will be connected to the main terminal. Like as shown here, this VSAT, very small aperture terminal, is connected to the satellite, and it provides connectivity to all the sub terminals. Yeah. So that it reduces the load, so that only there is a single connection established and sub connections are established from that.
Okay, so those are, yeah, I think comms on the move is pretty understandable. Hybrid multiplay is also understandable. And then backhauling, yeah, you're thinking about that more often and sort of like when you need a lot of throughput for the updates and so on. So that's kind of the use case for on the second bracket. Okay. Yeah, thanks. I got it.
Thank you, sir.
Thank you for both groups for well-prepared solutions and well-prepared presentations. Next up, we will move to the H&M groups. So the H&M group number 1, you can start whenever you're ready.
I believe that in the schedule, it should be Meso Autotech first.
Oh yes, I'm sorry. Yes, let's move on to the Metso Autotech group number 1.
Can you see my screen?
Yes, we can.
Okay. So our challenge was to create ideas and use cases that can take into account the new business potential of 5G technology with its measurable benefits compared to current technologies in place concerning the development and possible future services of mobile jaw crushers. So one major area 5G can be used to support is with sensors and video cameras. In these next 2 use cases, several different technologies that can be leveraged with 5G. In the use cases, there would be sensors installed on each vehicle and person that can give their orientation, position, velocity, and angular velocity, or their 6 degrees of freedom in relation to motion and position. Also, small enough 8K cameras with 360-degree view can be on each vehicle and person as well. The other technology I'll discuss is XR and AR, which require high processing power, high bandwidth to stream video, and low latency. 5G can help solve all these problems with its wider bandwidth, lower latency, and edge computing. So I want to introduce 2 diagrams that show requirements, different scenarios with the use of VR technology. Right now, 4G and other current networking systems are unable to provide these end-to-end latency requirements. But with the use of 5G, these requirements can be met since 5G allows low latency requirements of VR technology. We are able to get into the interesting and helpful use cases. So the first use case is an AR/VR site map. In this AR or VR application, the user can see the locations of all the vehicles and people represented as 3D models in the AR or VR app. This can only be done with 5G because to see all the movements in real time, as we saw on the previous diagrams, very low latency is required. Now with each of the AKA 360-degree video cameras installed, the user can tap on the vehicle or person to see what is going on in that location in the application in real time. If this is in an AR app, the user can view through the cameras while also looking in the real world. This allows for the possibility to view difficult to see areas. As you can imagine from the low latency requirements from the diagrams before, this all will require a very low latency, which is not something that can be brought with via or with a 4G. Only 5G would be able to bring this. And then now the second use case is with user safety. Since the sensors I previously mentioned have the position of the people and vehicles, we can create a system for when a vehicle comes near a person, the vehicle can be made to automatically stop. With the use of 4G systems, there would be a delay which is significant enough which could cause an injury. The AK video cameras can be used for anomaly detection and the environment using machine or computer vision, whether that is with from sharp objects or a deep hole in the ground. With this anomaly detection, it can be incorporated with the AR or VR sitemap. When the machine or computer vision detects something, a picture of that area can be taken, then tagged on the sitemap, where the user in the application can tap on that tag and view what the anomaly was to evaluate if something was significant. Again, as we saw in the diagrams with the low latency requirements, 4G cannot provide us with these capabilities. 5G is necessary here because we cannot wait a few seconds to have the vehicle to stop because an injury can occur, and we won't be able to view the VR app without 5G. So in the end, 5G brings very low latency to mitigate to prevent injuries in the field.
Okay, so in this slide, the top level idea is to use smart helmet with the real-time data to increase safety and productivity. And by using 5G, we will get mobility with reliable communication and low latency and high uplink capacity. In this slide, we actually have some use case examples which are related safety issues, data management, and productivity. First idea is smart glass integrated into the helmet, and second one is related real-time 360-degree view by using advanced camera systems. I just highlight a couple of use cases, and the rest of them you can read from the slide. Overall, the mapping users and machine locations in real time is a very useful feature of most of the location-based use cases. And probably one use case could be very useful from safety point of view. It's based on low latency requirements, and the idea is equip smart helmet, or it could be even vest with emergency stop switch, so that it can be activated very quickly by using 5G communication. Of course, this kind of low latency feature can be expanded to cover easily other functions as well, and can be combined, for example, with location information. Later on, we have a question sessions, and if you would like to more about these use cases, please do so.
Okay, so we propose to include the machines with scientific imagining equipment, such as sonar tools for measuring distance and detect obstacles. For example, when a machine is too close to a larger object, it might get stuck on, the machine stops moving. An employee can take a look over the situation over a safe distance. The high-res cameras we are also suggesting. Okay, the next slide, please. The distance data can be compared to other vehicular positioning data to increase position accuracy for the crosshairs. For flawless operations, it is necessary to have correct position of the crosshairs. The gathered data is processed in internal computing unit, and it can be sent to localized MIC cloud for fast data transmitting. Okay, and the final slide.
So local track urban series crushers can suppress dust by 85% and reduce noise by 60% with its internal water spraying system, including high pressure water sprays and other components, allowing it to crush next to residential areas, thereby cutting emissions and costs from transportation significantly. Automating the spraying system with 5G's real-time data management and other properties, you could ensure that the proper amount of fluid is sprayed for the exact time required and the right amount of pressure is applied depending on the drag of air and the impact wanted. The consumption of water, electricity, etc. could also be controlled better and even reduced. 5G could run maintenances more frequently and faster, checking corrosion, caking, and other negative factors through which spray performance can suffer and cost can rise, thus prolonging the lifespan of components. The amount of work is claimed for the spraying system in Metso LCS and Metso Metrics could also be reduced. So productivity increases, the process becomes more water efficient, and emissions are also decreased, at the same time contributing to the handprint part of Metso Outotec's sustainability agenda. Thank you.
And now if there's any questions.
Thank you so much for your presentation. If there's any quick comments from the challenge owners, please, you can share them.
Yeah. Jaakko here. So thanks for the use cases. I think these are actually really good ones and relevant for our business. So I think you guys finally got to the point what I was kind of looking for. And of course, these are still a bit on high level, but at least now we have a lot of ideas what to dig deeper. So I think I'm happy to see these kinds of concrete real-life examples and ideas that we can actually take further in our business. So let's see what comes out of this. But I think I saw a lot of potential in many of these. So I think I'm really happy what I'm seeing.
Thank you so much. Next, we will move to the Metso Outotec group number 2. Please start when you're ready. And I would like to inform you that we have the 7 minutes limit on presentations, and I would like to kindly ask every group to respect that, so we don't get any latencies on the schedule. Thank you.
Can you hear me? Yes. So, hello, we are Reinis and Marcus from the Metso Outotec Group 2. So, 5G, what's all the fuss about? The challenge we received is from Metso Outotec, a company that has been delivering solutions for demanding aggregate applications worldwide for over 150 years. They already have a Metso Metrics IoT and provide fleet management solutions that utilize cellular connectivity. So what is the added value that 5G brings?
So here is overview of 5G versus 4G. 5G has better speed, latency, connectivity, and efficiency. These numbers have been seen everywhere on 5G advertising. Impressive numbers for sure. But why would anyone care about these specifications? What are the benefits 5G brings and what it enables us to do in our ever more connected future? To answer these questions, we will look at automation and benefits it will bring.
So we envision a near future with high degree of automation in and between the Metso Outotec machines. As the future workplace becomes more automated, humans and machines will have to work together. For this to happen, we need to ensure that the workplace is safe for both. To create an environment where machines and humans can cooperate, we need machines to be aware of human activities on site. This can be done by deploying large arrays of sensors, but these sensors need to be reliable and low or even maintenance-free. In addition, they need robust connectivity and high data speeds. This is where 5G comes in. As pointed out in the given challenge, the customers of Metso Outotec and in business in general, they do not care about the technology, but about the benefits it might bring. Living up to this, we will next go into the benefits of said automation. So benefits: workplace and worker safety, predictive maintenance, efficiency.
For human safety, low or maintenance-free uniforms with multiple sensors that don't have risk of running out of batteries, always in operational conditions, are needed. Multiple sensor arrays that can monitor human harmful pollutant levels, such as micro dust particles, gases, and others. Uniforms that can send human whereabouts to machine so that machine can adjust their operations depending on human activities. To give an example, if human wanders in dangerous area, machine can go into low power mode or completely shut down and restart when it's safe. Human is left or send warning to human about danger. In unfortunate case of accident, machine or human uniform can immediately report incident, make a call for emergency responders, and machine can automatically power down in an incident area without interrupting the rest of the operations. For predictive maintenance, for the predictive maintenance, allow locating failing parts in advance. That ensures ensuring that they can be replaced before failures happen. That could cause cascading failure events to occur. Maintenance personnel does not need to first troubleshoot system to locate issue and attempt to fix it. It takes time. May need to order new parts for issue that was unknown beforehand. Instead, with high precision, exact failing part can be identified by help of multiple sensors located around machine that recognizes failing parts well in advance and allows for maintenance to be prepared well in advance. Knowing exact issue and parts that are needed will simplify the maintenance work and ensures downtime is minimal.
Dynamic load. With large array of sensors scattered across the machines, all machines can communicate with each other, allowing for dynamic load adjustments based on incoming loads. This means that each machine can tell the next machine in the production chain what weight and size the upcoming load is and an exact time when it is ready to be dropped. Based on this information, the other machines can adjust their power through lowering engines' RPMs while waiting or increasing them in preparation for a larger load. This will significantly increase the throughput of the production while lowering all energy consumptions and emissions. Here's a short part of a video illustrating a situation where a dynamic load adjustment can be applied. So this is just a simple case of two machines working together, but there can be production lines consisting of multiple machines in series. Automation leads to enhanced individual productivity as less time is spent waiting to do a job or doing something very slowly. The workers can instead focus on other tasks or simply oversee and operate multiple machines in tandem. Automation allows for non-stop production through the night with minimal oversight. This means increased production and less taxing work.
Okay, so how we can achieve it? Adding hundreds of sensors to machines and human uniforms is not feasible if we need to worry about batteries and wires. Combining low power requirements of 5G, we can create sensors that are powered by energy harvesting. This eliminates need for complex wiring and batteries that need to be periodically replaced. These sensors are more environmentally friendly as they do not need extra materials and chemicals for wires and batteries, also lowering cost of production and maintenance.
Thank you for listening.
Thank you so much for your informative presentation. If there's comments from challenge owners, please show them for the group.
Yeah, again, I'm very happy to see what I see. Good presentation, clearly put. So in that point, no questions. I think, and what I actually like from both team challenges is that they are not overlapping. So they are taking a little bit different angle, and I can definitely use ideas from both presentations. So I think this was taking the bigger picture in that sense, but again, I can immediately think about some practical use cases in our businesses where I could apply these ideas. So very good. I'm happy to see this. Good work, guys.
Thank you so much for both groups. Next, let's move on to the H&M groups. And H&M group number 1, stage is yours.
Can you see my screen now?
Yes, we can.
Okay, thank you. So hello everyone. We are the first group that tackles the challenge given by Ennis and Morris on how can we use 5G to transform the shopping experience. The big question is how can we utilize the 5G technology to give the brick and mortar stores the boost that they need over their online competitions. And to lively present our ideas, we have drawn some really interesting comic strips from the customer point of view. So as younger generation of customer are becoming busier and busier with their daily life, they have less time to come to the traditional store and shop. But when they do come and shop, they require these immersive experience that is personalized on all levels. And we have come up with a lot of ideas of 5G application that can give the traditional store these advantages that can meet the demands from the customer and give the customer a more enhanced shopping experience. And we will present our idea by taking you guys with us on a shopping spree at H&M. So first, when you walk into a store, you would notice the advertising board, but these advertising board at H&M are no ordinary board. They are interactive augmented reality board that can detect the faces and then put on the newest collection from H&M onto your body. And we will also install these board outside the window store. So when the customer stop outside the store, they can see how great they look like in our newest collection. This is a great way for us to market the new collection, as well as drawing the customer attention so that they would want to visit the store and eventually buy the items.
So when a customer enters a store, they open their H&M app and have their personal QR code scanned. This allows the customer to be recognized and be connected with their own purchase history. At the store, they can be offered more personalized recommendations and advertisements and receive personalized discounts on products. If a customer does not identify themselves through the app, they can still be offered recommendations based on their demographics, such as age, gender, and clothing that they're wearing. This could manifest itself as individual pricing in stores that can be updated for each customer on electronic price tags. So if you know from the customer's purchase history what they are likely to buy and what not, individual discounts and advertisements inside the store can be targeted more effectively to close a sale. And at the time, you are not offering unnecessary promotions and items that the customer is willing to pay the regular price. Similarly, the price tags can also be utilized to show the current level of stock for the specific item, creating a feeling of urgency, enticing the customer for purchase the item before it runs out of stock.
And in order to allow for a more immersive experience, we would like to install augmented reality mirrors all over the store. So especially for those customers who are too busy or do not wish to enter the fitting rooms, they could try on the clothes on these digital mirrors. and the mirror would show how the clothing item looks like on the customer. The customer could also alter the size of the clothing item as well as the color, and we will get the measures of the customer once they have entered and recognized themselves via the QR code onto the store. If the customer does wish to enter the fitting room, we would like to provide them a more personalized experience. So once the customer has identified themselves, we would get their personal preferences based on music and scent. So it could be connected to their favorite Spotify playlist that would then play the song on the fitting room. And additionally, the lighting of the fitting room could also be customized based on the occasion that the customer is shopping for. If they are shopping for a picnic, the lighter could be brighter than if they're shopping, for example, for a dinner occasion.
If the customer has their payment information connected to the H&M app, through which they have identified themselves, the customer can walk out of the door with the products and they'll be charged on their account. On the other hand, if they haven't identified themselves, they can still utilize the traditional cashier.
When the customer is happy with what he or she found at the shop, there are always situations when they want to return the items. So 5G would enable a very new smart feature. For example, the customer can just use the app to scan the clothing item to see if it's available for return or exchange. That is very convenient and time saving. And as you can see, thanks to the personalization policies, each customer will have the very personalized promotion. So there are some examples such as the single sale or student discount or new customer discount. So the discounts are very personalized to each individual, and that is what will make the customers very happy. So certainly 5G does not benefit the customers only, but the H&M company itself also. So we are trying to draw CEO of H&M, Helena here. So the benefits of H&M, of 5G for H&M would be, first is the improved inventory management, because 5G allows the items in the inventory to be tracked in real time. That would increase the accuracy. Also, the personalized policies would increase the customer loyalty, and that would overall increase the H&M's power on the market. And lastly, with all those new policies, that they will definitely decrease the advertising cost, and those are the benefits that we think 5G can bring to H&M. Thank you very much. This is our presentation for the benefit of 5G on traditional stores of H&M.
Thank you so much for your great presentation and creative solution for the challenge. I would like to ask the challenge owners to share your comments and thoughts about the presentation and for the group.
Yes, hello, Jari. Jari here. I'm answering behalf of Hennes Moritz. So I wrote some notes in the chat. So just check those. Excellent presentation.
Thank you so much. Next, let's move on to the H&M group number 2. You can start when you're ready.
Okay, can you see this?
Yes, we can see and hear.
Okay. Hello, we are going to talk about how 5G will make H&M stores better in the future. Problems with traditional stores. Shopping in real life is often more slower than doing it online. Sometimes it's hard to find items you're looking for. Traditional stores aren't as personally tailored for customers as online stores. Problems with online stores. You can't try your own clothes. Oftentimes the clothes you order aren't what you expect. You don't get the same experience shopping online as you do in real life. Our solution, a store that blends the lines between online and indoor shopping.
The first thing you will notice when walking into the store is a big AR mirror that lets you try on
and order clothes without ever having to find them and go into the dressing room. Next slide. And the H&M app will have three main features: indoor navigation, a recommended section, and clothing data. So in the indoor navigation features, items in the stores will be tracked using cameras that constantly stream video, and computer vision will be used to keep track of the item's location. And the customer will be able to find the items in the H&M app and by pointing their camera at the ground, and the shortest path to the item will be drawn using AR. In the recommended section, AI will be used to recommend the customer coupons, sales, and items based on their gender, size, previous purchasing patterns, and age. But this will cause issues with the GDPR, so it will be an opt-in feature. And in the clothing data feature, there we will use augmented reality to embed the items in the store with data such as data about the supply chain, size and materials, and product reviews. And the customer will be able to see this data by pointing their phone at the clothing piece with the H&M app. Next slide. And if you don't want to use the H&M app, you can ask a robot assistant in the store for help, and they can recommend you items based on the same data as the app uses, or they can show you where an item is in the store. Next slide. So in conclusion, when a customer walks in the store, they will find the optimal route to an item that they want from the recommended section. Then they can view the product data of the item using AR to make sure that they want to buy it. They can try on the item using the AR mirrors. And if they are having any trouble, they can ask the robot assistants for help. Next slide.
So why 5G then? 5G acts as a catalyst for the digital transformation. With 5G, it's possible because it's low latency, high, more traffic, and increased battery performance. It helps in achieving fast data processing in real time, provides virtual reality and augmented reality from anywhere, everywhere. Next slide. Now, what do the business owners they receive with the 5G? Connectivity in physical store means device can constantly exchange data with each other. 5G networks will achieve 90% reduction in power consumption with up to 10 years of battery life. With this, retailers will have access to smart shelves and use sensors to update price and other stocks accordingly. Also, 5G will assist in opening of pop-up stores and will also increase the point of sale in various areas. It will help to deliver a full and omni-channel experience connecting digital and physical world. 5G will revolutionize the logistics also. It will improve efficiency in fulfillment tasks, greater connectivity, and improved reliability will help communication between different brands, consumers, and couriers. 5G AI along with IoT will enable more accurate real-time data to flow, ultimately facilitating smarter system, which also means greater efficiencies and accuracies on optimizing the stock level, forecasting inventory, and also sales associates spending more time on the customer care. How will retailers interact and engage with customers before, during, and after sales are new benchmark for merchants, and thus 5G will boost big data generated insights about the customers. These data-based insights would create opportunities for mass customized and relevant services as personalized self-display, real-time integration of external partner data source, and more. IoT-based solution enabled with 5G-based facial and object recognition provides retailers with demographic data on who is in the store and thus provide sentiment analysis on products offered. It also helps to track the suspicious activity and also assist in smart energy and facility management in store. That is smart lighting and water running at optimized cost. Next slide. Now, what the customer receives then with the 5G? With the increased capacity of 5G network, the customers will experience complete augmented reality, virtual reality in physical store. With H&M app and VR glasses, they are able to check the product materials. Same app will also guide customers to the product they want by projecting direction in the field of view using 3D navigation technique as described earlier also. If the users are confused with the lots of choices, AI can also use the last buying decision and personal behavior and can thus recommend the product. Advanced dressing room of the future, filled with interactive magic mirrors, can also recognize the product through RFID tag. And instead of trying on with different options, click and check options will help customers to check the size, color, brand, etc. Magic mirrors can also be used to display personalized ads in real time, such as necklace or pair of shoes which perfectly match a dress. Traditional checkout stands will be obsolete with 5G. This technology will allow customers to scan labels with their smartphones to instantly pay for items. Shopping carts can also be fitted with checkout systems, monitoring items shoppers put into it or take out, charging them afterwards also. So next slide. That's all from our presentation. Thank you.
Thanks. Thank you so much for your informative presentation. I would like to ask the challenge owners to share your thoughts and comments and maybe questions for the group.
Yes, Jari again, on behalf of NS Board, so thank you very much. So I brought again some notes, so excellent solution, and I like also the idea of robot. So I led this presentation to be delivered from NS Board representatives as well, and we get later feedback as well. Thank you.
Thank you so much for both groups. Next in order, we will move to the University of Lagos groups. And first up, we have the Traffic Optimization Group number 1. Stage is yours.
Okay, yeah, so our project was about traffic optimization in Lagos specifically, where there are horrible traffic jams. There's a population of 20 million and people spend on average 4 hours in traffic daily. So we need a creative solution to increase productivity, improve health, and optimize routes for ambulances, etc.
The main solution we thought about is a mobile app, and we want the app to be simple for the user, so it's easy and convenient to use. And first I'll go through the proposed app idea from user's perspective. First, we have the starting point, which is by default the location of the user, because you usually start your driving where you are. Then we have a button to switch destination and starting point if you are, for example, planning a route in advance. Then we have the destination field. You can search the destination using the field or select it from the map. Then we have the button to create the routes. So it creates a few fastest routes and selects the fastest one. So you can select the route which you desire if the fastest one for reason or another isn't something you want. And then we have the drive button, which starts the navigation mode of the app and starts sending the data to the traffic light controllers. And last button we have here is more options, so you can enable like traffic overlays and adjust the settings of the app. Basically, this app knows users' location and route, and that information is sent to the traffic light controllers. The traffic lights rewards the users of the app by being unbiased towards them. So that basically means that the app users will get green lights faster. And that is how people are going to, how we are going to get people to use this app, because Lagos has quite a traffic, and faster green lights to you, of course, is quite a good thing when you are already spending 4 hours a day on the roads. Also, the app would have a special version for emergency vehicles, which overrides other road users in a way that the route of the emergency vehicle will be cleared up as well as the traffic lights can in advance while the ambulance is still coming. So the traffic lights can clear traffic lights intersection like way before, like 5 minutes before the ambulance is even here. And what is one important thing for us is that the app will be mostly like Google Maps, so users will not be like alienated from the app. Because Google Maps is generally known as good navigation app, and that is why I propose the app should have the Google Maps API for creating routes, because Google already knows very well the fastest routes. But on top of that, the app can also add its own calculation. So if the app knows that like 100 people will plan a route on this road, like in the next 5 minutes, it might detour some people to use other smaller roads instead, so everyone can move faster to where they want. The app requires citywide low bandwidth networks such as the LTE-M network or 5G, and according to my knowledge, Lagos right now does not have a very widespread LTE-M network, so it makes sense to build a LTE-M network using 5G to lower latency and other delays for communication between the traffic light controllers. This unfortunately means that heavier investments will be needed at the traffic lights because the data moved via, for example, the LTE-M network or wide coverage 5G networks can't be very high. So the data needs to be processed at the traffic light controllers, which then need to be replaced the controllers which actually have processing power instead of just a clock which uses set pattern to change the traffic lights. It also is possible to integrate the functionality of this app to Google Maps, which of course means that people will use the app basically automatically. But the problem is that it might be hard to get both the location and route via Google directly. And also other adjustments to the app, such as getting the special version for ambulances might be hard via Google, which is why we went with our own standalone app.
Okay, so now we will look at how the data gets from the phone to the traffic lights. First of all, we use time difference of arrival method to get the location of the phone. In TDOA, we use the difference between measured propagation delays to get the location of the phone. This requires multiple base stations, but the plus side is that we don't need time synchronization between the base stations and the phone, only between the base stations. So after we have the location of the phone, we send the location and the route the user has selected to a controller nearby with a 5G connection. One or more intersections can be taken care of by one controller. The more traffic lights we assign to one controller, the more we will need processing power on that controller. However, the crucial factor in the system is the delay. The more we add a cable between a controller and a set of traffic lights, the higher the latency will rise. After the phone's location is sent, the controller that received the data can then communicate with other nearby controllers via cellular communication, so the traffic lights can be readjusted. When more and more people start to use the app, we can achieve green waves. This means that the traffic lights are coordinated to allow continuous traffic flow over several intersections. The user's phone will continue sending its location to nearby controllers to confirm that the user is following the route and to check the user's speed. We need the speed and the position to be updated to be able to predict when the car is closing in on a certain intersection.
So we decided that it would be best to only use mobile phones and our app, which is integrated into Maps, because using sensors or cameras to detect where the cars are would be too expensive and require too much resources. And there could be edge intelligence in traffic lights, which would use low bandwidth waves, radio 5G, and or actually there could be regional edge stations every 10 kilometers, which would use high bandwidth, and the controllers could use machine learning algorithms to manage the traffic and could be connected by 5G. And are there any questions?
It seems like there's not any questions, so we would like to hear thoughts and comments from the challenge owners. Okay, I think the challenge owner might not be actually here at the moment, so let's move up straight to the next group. So traffic optimization group number 2, you can start when you're ready.
Good morning. Our challenge is University of Lagos Traffic Optimization 2 using 5G. So here is the outline of the presentation. We have the introduction, causes of traffic congestion, current solution in use, proposed solutions, non-intrusive data gathering features, solution outlook, ways to optimize traffic, simulation, and then the animation of the presentation. Introduction. Traffic congestion is a condition on roadway which can be presented as slower speeds, longer travel times, and increased vehicular queuing. It has caused a lot of inconveniences to people's life and work. Traffic congestion is a great challenge, especially in African countries. So causes of traffic congestion. We have overpopulation, lack of planning of city roads, traffic accidents, disabled vehicles, road construction or maintenance, adverse weather conditions, demand fluctuation, unsafe driving behavior. Then we have the lane violation.
Okay, going further, we're looking at current solutions in use. Now, so many solutions have been integrated to solve the problem of traffic optimization. It may interest you to know that there's a difference between traffic congestion and traffic. Traffic congestion occurs when there are of motors. Radio reporting. In Nigeria, radio reporting is a common solution to traffic optimization. Google Map, Waze, MapQuest. Last week, we explained the difference between these two. That Waze is a feature. Waze is an app that is more user-friendly because it has a voice prompt feature that enables user to impute, I would say, the conditions of the road. Now, what is our proposed solution? Now, how can 5G be integrated to traffic optimization such that we can be advancements in traffic flow of the road? Now, 5G can be utilized to automatically deliver real-time information of specific events on the road. Imagine driving, you are going out, you are going for an event, and you check your Google Map. Google Map will show you red line, okay, some things are happening, it's traffic on the road, but you don't exactly know what's happening on the road. Sometimes I have an issue, I had an encounter, I have a similar case whereby what was causing the traffic was not actually a serious traffic. It was because of just maybe the fuel of a car finished on the road. Now, when you see that type of thing, you don't exactly know what's happening. But when you use 5G in some non-intrusive data gathering feature, you can know that, okay, what exactly is going on the road? So, but how can we get information from how can we get information of the road without understanding, how can, what are the non-intrusive ways of gathering data? So features that we can use velocity sensors, we can use seismic and vibration sensors in these 4 motion sensors, which we explained last week. But looking at it now, how can 5G come into play here? Now, 5G is fast. 5G is very fast. So, but when we gather all this information, the information coming from the velocity sensor, the information coming from the vibration sensor, the information coming from the smart AI camera. Now, your phone has our phone has motion sensors that are not being utilized. The only one that being utilized is the GPS. But how can we now? So when we gather all these things together, we can use it to optimize traffic. Also, changeable message signals can also be used to optimize traffic, because when for this one that we presented here, there's roadwork to exit 58 right shoulder. Okay, now when you're going on the road, what exactly is happening ahead? So I want to know what is going on ahead of the road so that I can understand, so that I can better drive well, and there will not be issue of.
The low latency network of 5G can help us to integrate all these sensors together. And taking a particular case of the AI camera, we can see that apart from getting the detailed information in form of picture or video, we also can get the information from velocity sensors, from the GPS for location, and the vibration sensors on the road, which can tell us when there's an accident. We also have used AnyLogic simulation software to get a logic, to build a logic and try to simulate how this case would work for our university, which is the University of Lagos. And in this animation from the simulation, you see cars coming from the right were coming from the Unilag gate, and then from the left, they are coming into the gate, and an AI-enabled system, traffic light system, can help to reduce the traffic congestion in this particular case with the application of the message signs and other things that have come into play. So we just wanted to show you this for our university as a case scenario. Thank you for listening.
Thank you so much for your informative presentation and creative solution for the challenge. Let's move up straight to the Lagos University. Lagos University Security Group number 1.
Thank you.
Are the representatives of Lagos University Security Group number 1 here? It seems like there might be a little technical problem, so let's move on to the Lagos University Security Group number 2. So you can start when you're ready. If anyone here?
Oh, is it good dogs? Yes. Well, good morning.
Yes, it's yours. You can start when you're ready.
Okay, so. Can you see the screen?
Yes, you can.
Okay, good morning. So this is Security Group, University of Lagos Security Group 1, and group members are Louis David, Anache, Kadia, and Juan. we are going to be proposing a solution to combat insecurity in Nigeria. Some of the challenges faced currently are robbery, terrorism, kidnapping, farmers, headmen clashes, and many more. Because security also involves fires and escape ways. So the solution that we propose is the use of drones and CCTV cameras, smart drones to be precise, which can communicate with both CCTV cameras and with themselves. This will kill the problem of low drone range so that in case we need to pursue a culprit, the drones are smart enough to send information to another drone which is close by. So advantages of using drones is that it is non-static, it's stealthy, it can follow the culprits without them knowing, and they don't really have any blind spots. Plus, we get the real-time surveillance. And the use of the traffic lights, or not the traffic, the CCTV cameras, they are not really affected by bad weather, unlike drones, which if it is raining, they won't be able to fly or view as efficiently as they can. And they have night vision capabilities. So the implementation of, to make this a success, we need 5G technology, an algorithm for the interaction between the drones and the CCTV cameras, the HQ, as well as other infrastructure. This diagram shows the map flow of how the CCTV cameras, the drones interact with each other and the agents. From the crisis, the drone and CCTV camera picks up the issue and sends it to the security agent, which then starts to respond to the crisis. But in so doing that, the model system broadcasts to the app, which then interacts with the citizen. We'll be viewing this in more details shortly. Here is a pictorial view of the security agent's broadcast feed. As you can see from the CCTV camera, we can see that in case they see an incident, safety instructions are sent to the citizens, which in turn respond. And for the citizens app, there is an option, a safety option. There's a warning. As you can see, there's a warning. You have 40, this is a simulation. You're 40 kilometers close to danger. Then he asks you to confirm your safety, yes or no. Then in case you're safe, you say yes. If you're not safe, no. Then you can use the safety instructions to get to your safety. There's also an option to call the security agents for further help. Here are just the screenshots of what has just been shown in the link for further details. So I will strongly believe that 5G technology is possible in Nigeria, which has enormous advantages, not only the speed and low latency and the way the technology is structured. It can be used to solve a lot of problems, which is not just limited to security, but because of the context of this challenge, we shall be talking strictly about security solution. Lagos is one of the most populous states in the world, and a lot of insurgency and kidnappings actually go on. So practicalizing of this idea will help to save a lot of lives and better the livelihoods of the citizens. Some of the limitations of the drones and the proposed solutions, we were going to utilize solar power drones to utilize the high sun exposure of Nigeria being located at the equator. Also, definitely 5G technology infrastructures will be limited. And as said, the limited drone range, incorporating 5G technologies and strategic locations of the head. Okay.
So here are the locations in Lagos City, in Nigeria. And here is the app for security agents. Below here is Citizen app, where you can report the crime or crisis to security agents. And as you know, these video footage are shown by CCTV and these are shown by drones. There are safety instructions here. And these are the people who have reported the hazards. This. And this here. Can you hear me?
Yes, yes.
And this here is an app for citizens. And here you can see the video footage locations all over the city. Here is the warning instruction, and you can report whether you're safe or not. Right now I'm saying that I'm safe. And here you can call security agents via message or phone call. But let's move on. And as you can see, here is our app as a photo. So let's skip to 5G technology in Nigeria. David, can you continue?
All right, no problem. Okay, we believe 5G technology is highly possible in Nigeria. From the meeting we had with our mentor yesterday, SPAN, they already have a similar project working on a rural area, farms. The name of the company is SPAN. And they said the drones and the CCTV cameras, they communicate with each other, and there's an algorithm. So there's no real need for this drone communication, this drone CCTV camera communication. So this really saves a lot, makes it very efficient in catching culprits or highlighting potential hazards or hazards that are seen. And all of this is possible with 5G. So the most important thing being the speed of 5G will enable for this challenge to be successful is the speed of 5G, which enables security agents, citizens to be alerted almost instantaneously, and can save a lot of lives, because even a 2-second delay can be a determiner to whether somebody lives or dies. So next slide. Next slide. Okay, yeah, this is just a small video feed showing how the potentials in Lagos. Lagos is one of the most populous states in the world, actually. And there's a lot of highways, there's Third Mainland Bridge. There are a lot of rural areas still, but although Lagos is more developed than most of the other parts of Nigeria, a lot of insurgency still happens. There's kidnapping, there's robbery, there's banditry. All of this will be possible with implementing this idea to solve these problems, at least on a bigger scale of things. All this footage just shows how the structure of some of the parts of Lagos are. Can we go to the next slide? Next slide. Okay, yes, the limitations and the solutions. So when we're conceptualizing the ideas, limitations of drones battery life, even when we talked to our mentor, he told us. So the solution we propose is using solar powered drones, which utilizes the high sun exposure in Nigeria. Nigeria is actually a very good spot to utilize clean solar renewable energy. And lack of 5G infrastructure, definitely the solution will be to implement this 5G technology in this part of the world. Limited drone control range, as we spoke earlier about the interaction between drones and CCTV cameras, the algorithm will be able to tackle this lack of drone range. Since the drones can communicate with each other, a drone that is far from its range can communicate to another one, which is able to pursue a culprit. And also inclement weather. We use utilizing CCTV cameras with night vision to tackle this problem. Next slide, please. So displays, not only the app constitutes of a display notification and also sound notification, so that the citizens will get the information or get the alerts no matter what, whether they put their phone on silent or not. It will force the warning to come up. And also, so the displays are there to prevent panic, to give us safety instructions. And in case of fire displays, safety instructions are dropped so that citizens know what to do. Next slide, please. Communication, the alert system has already been mentioned. And please, next slide, has already been mentioned. Next slide, please. Okay, yeah, implementation of body cam or facial technology is another way to scale this idea. Because with this interacting algorithms, the efficiency of the whole system will increase tremendously. So some of the factors to consider is the location, strategic location, identifying the areas needed, night vision, the energy, the battery life of the drone. We're not just going to be utilizing solar power drones, but also it has backup battery in case a solar panel failure. Next slide. So yes, some of the stakeholders are the security agents, both private and public, the government at large, because they are ruling the citizens, and the citizens whose lives are to be saved. So as we talked about implementation, setting up of HQ, we need an infrastructure, and the purchase or implementation of the 5G technology, most definitely. Next slide. So this brings us to the end of this presentation. Thank you for listening.
Thank you so much for your extremely innovative solution to the challenge. I would like to ask the challenge owner Victor to share comments or thoughts or questions for the for groups. It seems like Victor is not here at the moment. So is the University of Lagos Security Group number 2 here at the moment?
Yes, why, yes.
Yes, please, you can start your presentation when you're ready.
All right, thank you. Can you see my screen?
Yes, we can.
Hey everyone, good morning everyone. This is the University of Lagos Team Security 2, and we are trying to solve the insecurity challenge using 5G technology. Trying to localize the problem, insecurity is very common in Nigeria, and trying to solve insecurity in Nigeria is very wide. So we took a particular case study, and the case study we'll be considering is the northern part of the country, where things are cases of kidnappings, insecurity are vastly common. Also, due to different things, we are going to focus majorly on highway and the insecurity that occurs on highway, things like kidnapping, things like drugging of properties, and unlawful killings that occur on these places. So examples of real life scenarios that have happened on the expressway being localized in this problem, we have crimes such as robberies and kidnappings along the expressway. We have motorists being killed and kidnapped. The Yoruba group calls for increased security on the Lagos-Ibadan expressway. Also, our doctors have referred to our president, Muhammadu Buhari, to tackle crimes on the highway. These are live scenarios of cases of which this problem it is we're trying to solve with 5G have been into consideration for what we are going to solve. Now, what's our solution? We are proposing an intelligent surveillance system. On our highways, we tend to have very high traffic lights or night lights. So we are going to be putting smart surveillance systems, which are going to be constantly monitoring these things and relaying the information to our NIMC database. So this is going to be in real time with the age of 5G. We are consistently monitoring things and movements that happen and occur, the different activities happening on these highways, and we'll be relaying this information back to we'll be relaying this information back to our NIMC database, where security operatives are going to be consistently monitoring this. So a breakdown of how this is going to happen. We have the installation of CCTV cameras along the expressway with night vision capabilities. Also, there'll be installation of 5G towers for low latency to make it real time and extremely fast. And we'll perform some data analysis and data compression, which will be doing real-time data analysis to detect criminal activities. And our NIMC database, which has consistent records of different criminals, both previous and newly apprehended ones, are going to be consistently stored. So this is the work breakdown of how this is going to work, and it's going to be occurring in real time, for which every time this occurs, what we are basically trying to solve is we are increasing the response time for which our security operative get alerted of a particular occurrence on the highway and how they can track such criminals and at the same time apprehend them effectively. Solutions, these are solutions, and who are the people who are needed to make this work? We have our citizens, yes, the National Identity Management Commission, national security agencies, the telecommunication companies, and also the government. If this is properly implemented, we're going to have faster response time. There'll be increase in the apprehension of crime. There'll be decrease in crime rates, and also there'll be an increased trust in the security agencies within the country. The members of this team are Munioluwa Jishafe, Abubakar Yusuf, Ayinu Kafo, Ifeoluwa Komo, Abayomi Green, and that's our solution. Thank you.
Thank you so much for your well-prepared presentation. I would like to ask if Victor is here at the moment.
Yeah, I'm here. Thank you.
Yes, please share your comments for the groups.
Okay, yeah, thank you. Yeah, I just like to thank the 4 groups that worked on the problems, the 2 problems we presented, the traffic optimization problem and the security challenge. Good presentations. Yeah, let me commend you for what you've done. What I can just say is that it's good to move beyond the PowerPoint presentation. Maybe I think it would have been good if we had more simulations. For example, the second group on optimization gave a simulation, and it would have been good also to push the simulation further by showing the effect. I mean, trying to simulate how decisions are taken intelligently using the data you're collecting and how that controls the traffic, how it influences traffic. So that gives a kind of POC, proof of concept, to whoever is listening, and that can lead to maybe thinking about how to fund the implementation of the idea. So what I say in general, it's been good, and thank you guys for what you did, and we can take it up from there and see how some of this could be kind of crystallized. Thank you so much.
Thank you so much, and thank you everyone. Good work. Now we have a 40-minute break, and we will continue after 40 minutes, and we will continue with Philip's group number 1. So please prepare after the break. See you soon. let's move on to the Philips group number 1. You can start when you're ready.
Okay, thank you. We are the Philips group number 1, and our topic of the day is POC ultrasound and REACTs for remote education and building teams in the labor rooms. Maternal and infant mortality rate is significantly higher in developing countries versus developed countries. Most of these deaths could be prevented with better care during the pregnancy and labor. 5G technology, together with easy-to-use, high-quality medical devices, can enable remote specialists to help midwives during the labor.
So our solution is in 3 levels. The first is hospitals and doctors who provide midwives with education and equipment. They analyze the data from Lumify and they help in the most critical and difficult labors. Then we have midwives who are the most active user of Lumify and REACTs. They are the closest support to mothers during pregnancy and labor, and they educate mothers on prenatal care. Then we have mothers who can track the progress of their pregnancy with a mobile app, and they will meet the midwife regularly during the pregnancy, and they could do breathing exercises to prepare for and help with the labor through the app.
At the healthcare professionals level, there is an international network of experts which can provide high-quality education for healthcare professionals in sub-Saharan countries. REACTs enables real-time interactive webinars, and virtual reality can be utilized for these training sessions. Midwives and nurses have labor room ones which have medical equipment and emergency kits. This enables professionals to meet mothers who are not able to visit hospitals or other facilities. With Philips Lumify, midwives could track the progression of the pregnancy. Initially, data collected would be analyzed by artificial intelligence, and if anomalies occur, doctors should investigate the data further. Hospitals should provide a private 5G network for secure and effective connection during critical medical care. During pregnancy, doctors can remotely provide midwives and mothers with personalized instructions to make labor as safe as possible.
And Lumify and REACTs are the things that connect all of these. So midwife uses a portable ultrasound, which is the Philips Lumify, and artificial intelligence can analyze the data and notify if any anomalies occur. In case artificial intelligence has found something, a doctor should inspect the data further. All collected data is compiled into a database in which a system based on self-learning artificial intelligence searches for critical cutoff values and similarities between cases and provides analysis-based treatment guidelines by calculating risk classifications and categories. The training of midwives can be arranged remotely by combining Lumify, REACTs, and extended reality. The International Medical Network could help in analyzing data, which would be a more effective use of kind of free doctors, and specialists can remotely support less experienced doctors in performing, for example, in difficult C-sections. And we think this could be a pro bono based network. On the mother's level, we are proposing a mobile phone app for expecting mothers to track their symptoms during pregnancy. Based on this tracking data, a nurse can be sent over to perform an ultrasound on the mother, which is then analyzed by the artificial intelligence and a doctor later if needed. Tracked data should be available and combined with data from Lumify to make it easily accessible for the doctors and professionals during the labor. Tracking during pregnancy can also help prevent miscarriages and maternal deaths caused by them. This app could also notify mothers when to book your next session with the midwife and include information about prenatal care. For example, it could have information about different breathing exercises and other stuff for preparing for your labor.
So then economical and ecological standpoints. Our business model would be to sell anonymous data to fund the project. Of course, a large amount of useful, unique health data would be collected during the project, and it could be transferred in real time through 5G. And this could be, for example, used to improve healthcare services in the future. And since public healthcare does not necessarily have the funds to have this project, then private hospitals would be the pioneers. The services would be free or very inexpensive for the mothers in exchange for the data. And we would like to utilize available doctors from all over the world. They could provide virtual support for the mothers and then VR training for the midwives. And then AI analysis and selection of critical cases would lessen the workload of doctors, which means a more affordable solution. And then finally, since not every mother necessarily has a mobile phone, our solution to that would be recycling used phones and tablets. Since mobile phone waste is a very widespread issue, over 9,000 phones are thrown out per second, it would be a very sustainable solution as it would make use of waste. Thank you.
So, thank you so much for your well-prepared presentation. I would like to ask the challenge owners to give feedback and share your comments for your group. It seems like
hello everyone, this is Alessia Struk from Philips.
Please.
Hello? Yes, yeah. I'm not sure if the rest of our team is on the line yet, but let me just say a few words. First of all, compliments, really well thought through business model and solution. A couple of comments. Also, part of this challenge is a standardization of care, standardization of information, knowledge, elements, so good also to think about that. And another element is education and training services that where it's good also to think about the target audience connected to the university, medical university, and connected to the local as well as regional global healthcare professionals. The team would like also to comment, to react, so very welcome to. Otherwise, really well done. Thank you very much for the presentation.
Thank you so much. Let's move on to the Philips group number 2. Stage is yours.
Okay, good afternoon, everyone. Can you hear me? Good afternoon, everyone.
Good afternoon, we can hear you.
So, okay, this is Philips Team 2. We are working on the point of care, ultrasound, and React for remote education and building teams in labor room. So, The problem statement is that there have been an high rate of infant and maternal mortality over the years, especially in low to middle income countries. So midwives for the bulk of the scheme, but attending to pregnant women accessing care or primary health facilities are low in LMICs. And so many LMICs adopting the use of ultrasound in antenatal care visits to detect anomalies during pregnancy and manage high-risk pregnant mothers, meaning in low to middle income countries, all the pregnant women actually need to visit an healthcare facility before detecting anomalies and everything. This late detection of anomalies can lead to the death of both the infant and the mother. So this problem, the impact of solving this problem would help teams in the labor room to be proficient and deliver care that will result in safe childbirth. It will also reduce maternal and infant mortality and in turn help resource poor countries to meet the SDGs. It also helps to decongest hospitals like in urban areas. So our solution to this problem is an end-to-end solution that will be leveraging the Philips Lumify platform. It will leverage 5G. It will leverage artificial intelligence, which is deep learning. It will also leverage Philips React system. So how will this work? Oh, presentation mode.
Okay, can you hear me?
No, I'm coming. So how this will work is that when the the pregnant mother starts uses the Philips Lumify equipment, the transducer for the ultrasound scan. So she does that on her own, and the data is being sent to the cloud, and the AI on the cloud platform can actually analyze the images from the ultrasound scan. So whenever like an anomaly is detected in the scan of the images, the anomaly can actually be sent to a remote specialist that can now look into the images like for further intervention. My colleague will take on from here.
Okay. I'll be talking about the business model we proposed for this challenge. So the key partners for this challenge will be partnering with private and public hospitals and non-governmental organizations who will be interested in reducing maternal and infant mortality. The key activities for this business model is the use of Philips Lumify to carry out ultrasound scan of the patients. The real-time images obtained from the scan will then be examined and interpreted by the artificial intelligence agent using deep learning. In case of emergency or abnormality, the system will alert a remote specialist for intervention. Then the specialist will communicate and examine the patient in real time using the Philips React platform. The key resources for this will be Philips Lumify, Philips React, 5G, and artificial intelligence. The value proposition for this challenge is the proposed system is an all-in-one that interprets a digitized pathograph, POC ultrasound scan, and Philips React. The collection of data and translation into a visual 3D model of the organ, which is the organ for pregnancy, for the detection of pathologies and illness. The implementation of artificial intelligence using 3D technologies to reveal the stage of the pathology, including selection of effective treatment methods. Early discovery of some of the illnesses will make it easier and cheaper to manage, hereby reducing costs and reducing life expectancy. Now, the customer relationship, the customers can interact with the doctors and midwives via the application in real time, and as well can get an automated response via the artificial intelligence through the app. In some cases where the doctors are busy the artificial intelligence can attend to customers by linking them to the Philips Customer Service Center. Then the customer segment for this proposed business model. The target market for this device are people living in urban and suburban regions. It will render services specifically for pregnant women in these areas. The channel of communication, we will be providing an email newsletter with company news and product information using targeted Google and Facebook advertisements, utilizing social media such as Twitter, YouTube, Facebook, LinkedIn, Pinterest, and the rest. And also, we'll be providing contact information on the Philips Lumify app. The cost structure of this service will be provided via Philips Lumify app. It will be very affordable and customers can subscribe monthly. The payment structure will be flexible according to the individual, and they can subscribe, and whatever they subscribe will determine the service they get. Now, the streams of revenue will be through membership fees and direct sales. My colleague will take from here.
Thank you so much for a well-prepared presentation and innovative solution to the challenge. If the challenge owner is here, I would like to ask you to share comments and thoughts for the group about the presentation.
Hello, this is Alessia from Philips. And again, if my colleagues are also on the line, please join in. Yeah, I think it's a great presentation, very well done. Great job, thank you very much for this. Well thought through also the technical side of the solution. And also interesting angle to capture the consumer part, so and patient engagement, and also professional in hospital value can be created also real time in the high-risk cases delivery. So I would encourage a bit to differentiate those. So there are several use cases mentioned, I believe, and then differentiate and think about also the technical side, how to solve this challenge. One part is the consumer engagement or patient engagement of mothers, providing them information, guidance, real-time images, potential visualization. The other end is actually critical care or delivery, and then what's the use case there, and the technology, the technological part of the solution, and also the business model. Yet, though, very good point to take the whole cycle in scope, because it's actually by identifying high-risk pregnancies earlier, then we are reducing the whole cost of care, in addition also to preventing maternal and infant mortality and improving experience of the pregnant women and families. Thank you very much. Well done.
Thank you very much for both Philips groups. Next, let's move on to the GNOST Agriculture Group number 1. Stage is yours when you're ready. It seems like GNOST Group number 1 representatives are not here at the moment, so let's move on to the GNOST Agriculture Group number 2. You can start when you're ready.
Okay, one moment. Okay, I think you should be able to see the presentation now. It's a 5G and artificial intelligence based solution for NASTA Agriculture 2 challenge. Okay. 5G is indeed a revolutionary technology also for agriculture. And here we list all the general and potential use cases which can be used in farming and agriculture: plowing, seeding, watering, harvesting, farm animal monitoring, and all of them are substantially enhanced or powered by 5G technology. And we would like to show our vision for the use of 5G in a couple of these use cases for Ghana. And we wish to put it in a smart farming actual market in Ghana. So we focus on the farming component of agriculture challenge. We do not touch upon logistics or delivery or packaging part, but rather on the farming, growing, and animal part of farming. What is 5G to smart farming? Despite that we have a lot of available technologies which work well and they bring a lot to agriculture sector, we think that 5G may substantially enhance the productivity and enhance the level of training of farmers, prediction technology as well. So we think that 5G will greatly contribute to farming and agriculture in general. Moving to 5G is mandatory in case of some related applications which require obviously real-time tracking or use of certain technologies such as machine learning and artificial intelligence. Obviously, artificial intelligence cannot be used outside of 5G, but in order to employ large swarm drones for seeding or for monitoring, 5G is basically mandatory or at the minimum crucial. And we think that enhanced machine learning techniques might be of benefit for farming sector, specifically for training and data analysis and preparing other farmers in their fields based on the experience of farmers who employ 5G technology and machine learning technology. What are the possible challenges to roll out of 5G-based solutions in farming in Ghana? One of the first challenges is proper legal framework and implementation of privacy laws. Obviously, there is a Data Privacy Act in Ghana, drafted and published in 2012, which is 9 years ago, and certainly needs to be updated for the purpose of employing 5G technology, since farming sector involves lots of people. A lot of personal data will be generated and then used and analyzed. A lot of machine-to-machine communication data, which might also contain personal data, will be generated. So there is a need to develop legal framework, both for protection of privacy and personal data, and if necessary to update other laws to allow the use of 5G and 5G powered and autonomous vehicles, such as autonomous tractors, combiners, and swarm drones. Another important challenge is network coverage, which is quite poor in Ghana, and we obviously have to take that into account, and that 5G network will be cover a very small territory at the beginning. So our challenge is concentrates more on testing it and testing the reach of this technology. And it is also closely related to infrastructure development. It's mobile networks, as well as possibility to repair and maintain drones and autonomous agriculture machinery. There is also a crucial need for education facilities. The need to divert more funding for university to train more experts, more engineers, more privacy experts, so that this human capital in Ghana can enable the push for implementation of 5G technology. And the final point we identified is management of technology. It is also closely related to education facilities. They need to train more specialists to manage this technology and effectively use it. This is an illustration to show the coverage of 2G, 3G, and 4G mobile networks in Ghana. And obviously, we can see that it is concentrated in the south of the country around huge cities where most of the population is located. So possibly the 5G network will also start its rollout from the south. And that's where we think our farming solution will take place. There are other things to consider, like migration to 5G is mandatory, as I said, for certain technologies, but for security concerns, we have to isolate the network, also through the use of trusted computing and network slicing technology. Solution must take into account the lack of coverage, so we will have to employ drone swarms to relay the signal to distant fields which lack the proper strong 5G coverage. We have to focus on education sector to train, as I said, more engineers and experts and facilitate international exchange, since it would be extremely hard to implement the 5G solution without international experience in Ghana. Also, we have to take into account the principle of security by design. We have to consider cybersecurity and privacy as crucial things while rolling out 5G, not only because of impact on people, but also impact on equipment and the threat of potential hacks or software failures. They may impact the very crucial agricultural sector. So the aim of the project is to provide a general roadmap, some general vision for Ghanaian farm sector on how to adopt these new technologies for agricultural sector. Our concept, on the right, you can see the population distribution map of Ghana, and it correlates with network coverage of Ghana. So we can see again that south of the country is populated more. So again, that's where we intend to concentrate our solution. And the main ideas of our concept is deploying a private standalone 5G network shared between farmers in certain small, at the beginning, geographical area, and then run a cost study and see what may be the potential optimization solutions. So we start with testing this 5G powered farming network, and then we see how it can be improved, also using drone swarms to relay signal to regions like distant fields which lack the signal. We also need to enable sharing the network between multiple farms and farmers, which will also make sharing data easier. So we will have to think about ensuring that privacy and personal data are protected, potentially anonymized or pseudonymized, so we can share this data generated on one farm with other farms, and all of them can facilitate their experience, and so the experiment is more is better, yields better results, and is more targeted. Specifications of the use of different network requirements for each use case. So we will have to adapt this solution for specific use cases. And we intend that this testing and then working network, proper network, will be used as a supporter for a wider range of IoT solutions and innovations that could be adopted for Ghana. They include not only agriculture, but since agriculture takes a lot of territory, we think that vehicle to infrastructure and logistics and packaging might also stem from this experience. And obviously, we will use gathered data for machine learning to improve our algorithms and then possibly use them for other sectors as well. The use cases, the exact use cases we can use in our vision is monitoring of plants and animals. It's information gathering and processing via the cloud, and also augmented reality modeling to see how the field may look like, whether the seeds how the seeds will grow, what territory it will occupy, obviously to a certain extent, but this farming foresight is possible, and augmented reality will definitely help yield better results. Second is machine-to-machine communications and data, ensuring remote driving, vehicle-to-infrastructure use case, harvesting, crop control, seeding. This is a very practical use case, so we can push this machinery, which is autonomous and much more efficient, can work at night. But we will have to use swarm drones to ensure that these machines are not lost to the signal or are not lost in general. And obviously, we can. The third use case is education tools for farmers. More practical training to show virtual reality field or augmented reality field to train new farmers and engineers to show them how technologies are implemented in real life. The outcomes of the solution is contribution to training and education, both professional training and theoretical academic education, engineering and agriculture, privacy. Second is push for the modernization of infrastructure in Ghana, specifically mobile networks, but also agricultural machinery. And third is development of expertise and contribution to related sectors of economy and technology. As I said, the agricultural sector may serve as a sort of locomotive, a push for related sectors of economy in Ghana. Thank you.
Thank you so much for your innovative approach to the challenge. I would like to ask if there's CNAST Agriculture 1 group representatives on the line at the moment. And if there's any comments or questions from challenge owners, you can show them now. If not, then let's move on to the CNAST Smart Campus Group number 1. You can start when you're ready.
Hello everyone, I am representing the CNAST Smart Campus Group 1. So for a short preview of what we're gonna talk about, we're gonna see the current situation, then the challenge that we're having, then the solution we're gonna suggest, and at the end a recapitulation of what we've just seen. So the CNAST campus, it's a university in Ghana, which has 80,000 students and a staff population of over 1,400 people. And with the current COVID situation, it has changed everything in the way they teach and learn in the institution, especially with laboratory and practical sessions. They have to be done online. And this is a big challenge currently at the university. So the main problem that they're having is with the current network. It is indeed difficult to share educational resources and information systems such that teaching, scientific research and technical services are hard to share. On top of that, the systems are often constructed separately, so the information is isolated from other part of isolation or information, and therefore the integration is quite poor of the process. Also, the capacity for the new services is insufficient. So if we want resolution in 4K or 8K, or if we want virtual reality, it's difficult to implement because of the current bandwidth. Also, the data security risks are quite high. some leaks can happen, and that would mean information about students' parents being leaked. And well, of course, the university doesn't want that to happen. And with big data happening, that could be even worse. So we need to protect that. And also currently the cost of maintenance and construction of the network is quite expensive, especially with the updates they need to keep up with. So basically the current fixed broadband plus the Wi-Fi and 4G networks on the campus, they can't meet the requirements for the new information and communication technologies, but those technologies are essential to create an online learning environment and a new smart campus. Therefore, the solution is to implement 5G on the campus. So the main advantages of 5G would be to unify the network. That means we wouldn't have to have multiple networks deployed on the campus. The bandwidth would be much higher, so that would help in online lectures and broadcasting and that kind of things. It also goes with a faster speed and lower delay, so people would be able to communicate online much faster and without connection problems. And 5G also would support some new application scenarios in teaching and education. So there are three main applications of 5G in teaching. So the first one is the enhanced mobile broadband. So that could be used in all kinds of teaching environments, from primary schools to universities. So that could help with implementing virtual reality or even artificial intelligence evaluations scenarios. Then we also have the massive machine type communications. So that would help for everything related to AI. That would make the management of the schools and campuses much easier. And then we also have the ultra reliable and low latency communication. And that would help with the interactive teaching that is made remotely. Then we also, so for the remote interactive teaching, because 5G has a large bandwidth and a low latency, it can support classrooms remotely with dual teacher classrooms. So as we can see on this diagram, there's multiple classrooms, but they're all connected. As we can see that one of the teachers is being broadcast in the other classroom, so that could create some dual teacher classrooms scenarios. Then we also have the application of VR and AR. And this is once again thanks to the bandwidth and latency that 5G can provide. And so we can imagine some scenarios where students are having some VR headsets on and working on their science projects or just experimenting. And this is also thanks to the cloud platform that is connected to the VR application. And then we can also apply remote listening and evaluation. So compared to the traditional methods, 5G, we can provide a guarantee that the evaluators can fluently receive HD audio and visual material. So that would help in some kind of exam situation. And then we also have the AI embedded evaluation. So that would be made with, for example, face recognition. And then thanks to some analysis and statistics made on the data provided, AI could send a report to teachers and parents to see so that they can evaluate their students. And there's also the smart campus management. So with IoT, we can connect all kind of devices on campus, such as cameras and sensors. And that could, for example, help in keeping the campus safe and secure. So overall, the advantages of 5G would be the educational environment would be more intelligent and adapt to every student and individual on the campus. And we could also have all kind of data and just educational information being transmitted on campus through a seamless circulation. All kind of high quality resources could be provided at any time that you want it. And also, it also promotes educational equity as anyone could access the educational resource. So there are but some disadvantages, such that the 5G network range is not that great, as it only covers around 300 meters. So you need a lot of antennas to be able to put 5G everywhere on the campus. Also, physical obstructions can impact connectivity. So simple things such as trees or just little buildings, they can impact the 5G network and cause some lags. Then there's also the initial cost to adapt infrastructures, and that is quite costly. And there's also the fact that everyone on campus, so students and staff, need 5G devices. And that would cost a lot to implement. And the 5G, it's also known to drain the device's battery. So if students' device can't last one day, then we need some kind of solution to charge them during the day of learning and teaching. And then there's also some differences between upload and download speeds. So that could be a problem when broadcasting and watching lectures online. So overall, we can see that a 5G would bring a new method to change the way learning and teaching has been made. But we encounter some problems since in Ghana, there's only 4G as of now. So the main mobile providers are Vodafone and MTN. And as we can see on the two maps, all the orange little dots, they represent the 4G network, but there is no 5G. So that causes a problem in terms of cost and required materials, as we can imagine that it would be quite expensive to have 5G made possible on the campus. So for that, we can imagine a cooperation with some mobile operators, or even other universities in Ghana, or even around the world, so that they could cooperate and make 5G possible on the campus. So thank you for listening.
Thank you so much for a great presentation. I would like to ask the challenge owner to give feedback for the group. It seems like the challenge owner isn't here at the moment, so let's move on to the CNAST group. Let's move on to the CNAST Smart Campus Group 2. Stage is yours when you're ready.
Hi, Lisa. I feel like you're muted. Did someone already start? Gonna Smart Campus 2. If someone's speaking, we can't hear you.
It seems like there might be a little technical difficulty, so let's move on to the group grant number 1, and after group number 1, let's see if CNAST Smart Campus Group 2 can present their presentation. But now, grant group number 1, please prepare to pitch.
Okay, hello.
Hello.
I'm sharing my screen. I
can see it. I can begin.
Yeah.
Sure. So hello, we're the group grant number 1, and we are Simonikit and Safalu. And I will begin by introducing us, after which Oladimeji will begin by describing some of his solutions and findings that he has. I'll continue after him, and finally Nikita will present us with some more solutions to this problem. So Oladimeji, are you ready to begin? Is he here? He could be thrown off by the change in order.
Okay.
Hello.
Can you hear me
Okay,
now?
good.
Hello, can you hear me?
Yes.
Okay. We're talking about the top agtech companies in the Nordic and Baltic countries. So we have the Simris Alg, which is located in Sweden and is on the coast of the Baltic Sea. And they're interested in Hauge, actually, because of its ingredient for food. Also, the Vital Feed, which is located in Estonia, is uses software tools to control field. Their system monitors weather forecasts, track crop phases, estimate threats of plant disease, analyzes data from the farm electronic feedback, and those help to make predictions on the field by helping users keep track of costs and grows crop more efficiently. And also we found out about High Farm, which is located in Finland, and they develop solutions in vertical farming. Thereby they created a technology whereby it enables one to grow fresh vegetables, berries, and greens. And also the top organic products in retails, we have dairy, vegetables, fruits, rice, bread, pasta, flour, goat meat, cold cold, spices, supplement, and so on. So 5G and sustainable development goals. We want to know how 5G can be able to help the food production chain in line with the SDG goals. So using of 5G and vertical farming and hydroponics, we help to reduce the usage of land, thereby keeping our forest reserves. Also, 5G will help to monitor water and energy usage for growth, thereby making the process a clean one, which will help to be in line with SDG goal 6 and 7, which is making clean water and energy available, using the XR/VR to be able to detect and get real-time information about these things. Also, SDG goal 2 will be able to be specifically about ending hunger. And so using 5G, we can be able to know in real time the areas that need much more food production and lower food production, and thereby be able to meet the needs of these people. Also, we can be able to use the 5G technology to also monitor the healthiness of this product from the production process to the food supply chain. That is, knowing which product is meeting the standards, and also when they are already going bad on the shelf. And also its importance can be overemphasized. We can move on to the next, please.
Also, blockchains have been proposed as a solution to power up supply chains of all things. And this could be achieved by implementing IoT chips with products to essentially be able to track them. And by using blockchains, we'd be able to build a reliable and unalterable way to track products through their life cycle. And this has a number of implications. For one, it would eliminate the need for trust in supply chains. And it would produce value for customers in that customers would be able to, let's say, when they're buying a product, know exactly where that product has come from. And it also adds value to the producers in that by knowing exactly where your product is and where it's going and where it's from, in case there's let's say a salmonella outbreak that caused a huge food recall in Finland not too long ago. These product recalls cost millions to the companies, and being able to more efficiently track where their product is and where it's going is able to reduce this. It also helps with improved food safety and gives a possibility to track and identify fake products. These IoT chips would also be able to gather information on relevant things, such as just delivery time or transport and storage conditions. And all this information could be used to make the whole supply chain a lot more efficient and reduce waste and eliminate need for as much storage. And all this is relevant, especially in Finland and Norway, as both countries have a large number of very small farms, and this has increased the need for transportation in these countries. Next slide, please. And Nikita will continue.
Yeah, thanks, Simo. I will proceed with the solution suitable for agricultural sector, and first start with drones. So the usage of unmanned air vehicles, also known as drones, has recently received significant attention from business communities. And the drones can be used in two use cases. First is a transport and logistics. UAVs can carry a load to a destination as a delivery tool. And this use case utilizes UAV's capabilities to change location between 2 points very fast and easily without being interrupted by restrictions on the ground. And the second use case is control and analysis. UAVs can help to optimize agriculture operations and increase crop production and crop growth by monitoring fields and processing high-resolution videos. And why we need 5G for drones? Because actually it appears that 5G is very crucial for UAV's operations. We also can enable machine learning at the edge to do computations at the edge devices. And also by utilizing ultra reliable low latency communications, UAVs are able to perform latency sensitive tasks. And in the end, UAVs connected to the 5G network may be coordinated in a safe and centralized manner. Next is IoT in agriculture. The benefits of IoT include precision farming. The goal of precision farming is to analyze data generated via sensors and to react according to this. Also, data analytics helps us to analyze the water and crop conditions. Also, machine learning as the edge can be used in this case. Another cornerstone of 5G, as we know, is massive type communications, which is brand new cellular IoT service for enterprises. And in this context, network slicing is coming. The network slicing here will create virtual networks for different segment services within the same 5G network. And these slicing capabilities allows operators to support different use cases and enterprise customers without having to build dedicated networks. And finally, we present the digital twins. So digital twins basically are virtual images of assets from real world, both physical and non-physical ones. So basically, the digital twins bring together all information regarding the real field, and this information is used for creating a digital twin of the field, and this information is stored as a digital twin and can be later used by applications and farmers. Right, thank you for your attention. Any questions or comments? If no, thank you very much.
Thank you so much for a well-prepared presentation. I would like to ask the challenge owner to share a comment.
Lars here.
Yes, please, Lars.
I want to say a few words. Yeah, you started a little bit earlier, so actually couldn't come in the end. I just want to say thank you to the team, and we'll have to look at it later on then and come back with questions to it. So thank you, team. Good work. Congratulations for now.
Thank you.
All right, thank you.
Yes, thank you, and let you all know that these pictures have been recorded, so they can be watched after this live session. Okay, next let's move on to the grant group number 2. And you can start whenever you're ready.
And just to remind you quickly that the pitches are recorded only for the mentors and the challenge owners, so that they won't be shared publicly anywhere. So no worries about that. Only your own challenge owner can view them afterwards if necessary. So a quick comment on that.
It seems like that grant group number 2 representatives aren't here at the moment, so let's move on to the NL group number 1. Stage is yours when you're ready.
Can you see this?
Yes, we can.
Okay, thank you. So the challenge we chose is 5G technology in wind power, and our idea is a remote controlled monitoring system that's done by using 5G and UAVs, which are unmanned aerial vehicles. And first we're going to talk about drones currently, and then we're going to talk about our solution to the current problems that they have, and then about the applications it provides, and then there's going to be a summary. So drones in wind farms are currently checking visually places that are otherwise difficult to reach or dangerous. They're keeping track of components like the wind turbines blades, doing aerial thermographic inspection, and erosion and corrosion examination. And with all this, they're able to plan preventive maintenance. So wind farms are usually located far from the nearby cities, and the drones are either field team controlled or autonomous. And they have digital and thermographic cameras, and some even have LiDAR sensors. And the way the wind turbine inspections work in practice is that first there's the wind turbine inspection that's done by the drones, and the data from that is then uploaded to the cloud. And then the information moves to the headquarters for an AI analysis and for a technician evaluation. So current issues with the wind turbine inspections. The drones are controlled only on site, or they're not controlled at all, like in the case of autonomous drones. And the disadvantages of this is that time and money is spent moving to wind farm sites, and even the autonomous drones need some level of human supervision. So with 5G, the drones can be controlled from further away and on larger area wind farms.
So the solution is to deploy this private 5G network, which is tailored for the remote operation of the wind farm. So the goal of the private network is to provide low latency, high reliability, and high data transfer, even in this distant location where wind farms are usually located at. This can be 10 to 15 kilometers or higher. This high data transfer and low latency would allow efficient and accurate control of this drones and UAVs, and also in addition the transfer of sensor data from the drones and the wind farm obtained, and then the data can be transferred to this remote operation center. So in essence, as you can see from the picture, the monitoring of the wind farm can be done remotely through the network. So the required components of this 5G network can be seen on the right picture. So this is the general 5G network setup. So in essence, the connection inside the wind farm would include these wireless base stations or G-node bits at the turbines or at some other substations in the wind farm. We would also need to deploy a base for this edge computing. These stations and the edge base would be connected with optical fiber or this fixed wireless access, which is a wireless way to transfer similar amounts of data as the optical fiber. The other 5G architecture would be located at the remote operation center, which would include the data management and the control panel. And the connection between the wind farm and this remote operation center could be done with fiber connection or this fixed wireless access, depending on the terrain. So this is how it could look like. The GNB antennas are at the turbines or at these other substations. And the UAV station, where the drones are controlled from and where they can be recharged and stored, would be located somewhere middle in the wind farm. This UAV station could also have this edge computing components and user interface. The data then collected by the drones or the sensors in the wind farm could be transferred to this remote operation center.
Applications. Having workers use UAVs from afar benefits the company in many ways. Some of the possible benefits include reduced costs, increased safety, and more efficient work time. Reducing the cost from traveling to the wind farms, which are usually located far from the city. Increased safety for workers as they are exposed to the dangers in the wind farms, for example, disjointed components. Workers have more time to do other tasks as they don't have to spend their time driving back and forth to the wind farms. More applications. Here are some other ways 5G can help in the wind farms. At the moment, wind farms need almost daily check for accidents caused by weather, batteries, sabotage, and so on. With 5G, transferring data and other information from the site to the offices becomes more efficient and faster. Weather data, for instance, can be examined without having the workers go to the site. In case the workers are wearing some kind of wearables that transfer data, the information from them can also be studied in the offices located in the city rather than on the site. Summary. At the moment, drones are being used in multiple ways in wind farms. They offer a big help and there is no going back to the times before UAVs. However, there has always been someone on the site physically using UAVs and checking sensors. Thanks to 5G, it is now possible to monitor the wind farms remotely. This change brings several benefits to the companies, such as reduced costs. Thank you for listening.
Thank you so much for a great presentation. I would like to ask the challenge owners to share feedback or comments for the group.
Hi, everybody. I like very much this this presentation. I like the number of applications that you I think to apply with this technology, and also in my opinion, thinking about it, there is a larger number. So also you have taken into account that usually in wind farms or in also other kind of farms it's difficult to have connection because they are located in places that are very far from the town, a remote location. So this could be a good solution to improve the quality of work and the safety of the workers. Thank you.
Thank you so much. Next, last but not least, we have the Enel group number 2. So you can start when you're ready.
Hello? Do anyone hear me?
Yes, we can.
Yes.
Today I will speak about yes, I can see. The next slide, please. Today I will speak about what can 5G do in a wind farm, how can 5G technology help make wind farms more efficient and safer, how can 5G technology simplify sustainable development. Reaching green wind farm areas is a bit hard mission for 5G waves. So here we should speak about feeding those areas and equipping them with all of its components, from antennas, microwave dishes, and outdoor isolated cabinets. Also, because we may be thinking about a wide area of coverage, we should use the brand new devices technology, MIMO. Those devices can be attached to the windmills, and as it's containing powerful amplifiers by nature, it will give us more coverage. For the long road trip distances of the wave, we have to mention Nokia and Qualcomm beside US Cellular, as they have achieved a world record for waves that could travel for up to 5 kilometers. Next slide, please. We know that the individual MIMO produces a number of beams, and the device set is free to choose the one that fits it perfectly. Also, we have only limited degrees of coverage for each MIMO, so we have to put the MIMOs in a proper places and good positioning. Connecting all the site with the network is too important in our case because it will enable us to control everything remotely, the thing that will reduce the dependency on the human factor. Next. Remoting is too important in our case because our green farm may be in a far area, so everything should work automatically and gives us real-time data day by day. Linking all of our windmills with one physical station will be a good idea. This will depend on the IoT and the edge computing that are major features of 5G. The physical station will store the measuring and the data of our green farm, such as the gigawatts that we have generated, the weather case, malfunctions, etc. After that, we could think about linking all the stations each other around the country, and this can be achieved if the data we have stored and analyzed were uploaded into a cloud that's shared among all of the sites. This definitely will help us to decide what is the next step Do we need more energy or some maintenance, or even do we need batteries to store some additional gigawatts?
So our main objective is to also build a weather monitoring system. So knowing the weather for today is something which is really important for the workers, especially in the wind farms, so that they can be prepared for any unwanted or unnecessary circumstances. And one of the main challenges is also to predict the weather accurately, for which we have also given a small solution. So this is our small system architecture. So in our system architecture, we have a Raspberry Pi, and we have 5 sensors: the temperature, pressure, humidity, rain, and wind sensors. So this sensor, along with Raspberry Pi, will be mounted on the drone, mainly for having a full coverage rather than being in a static position. Also, the data from the sensors will be moved to the gateway using virtual network functions, and from the gateway to the server also using virtual network functions. The server will be a common point for the base station, as well as for the storage of all the sensor data. And the sensor data will pass on to a machine learning algorithm, which will help us to predict the temperature, humidity, and pressure for the next 24 hours, the precipitation, if it may happen, and also help us to calculate the power which could be generated for the next 24 hours. And this data can also be seen using a mobile app like for the client. Next slide, please. So this is a small framework for our model. So our machine learning model is actually pre-trained model. It is trained on the data set of Environmental Protection Administration and the Central Weather Bureau in Taiwan. So it's the data set consists of about 50,000 hourly measurements in the last 6 years in Taiwan. So the model has been trained in that data set. So and also the model is based on LSTMs and multi-layer perceptron. So any data which passes on the model can actually predict our necessary data and be displayed on the screen. Next slide, please.
So we look forward to implementing the use of drones, basically for security and for maintenance. Basically, what we target is the security of the workers and the security of the wind farm equipments like turbines and any other electrical implements that are in the wind farm. So like in this case, we use high definition cameras mounted on the drones and other sensors such as smoke detectors for fire detection. And so like we want to implement an autonomous drone, which is working best simply because it will reduce manual labor from workers, someone needing to control the drones, or many people controlling the drones, which is a lot of work. So with 5G, with reduced latency, with a great connection, we can implement autonomous drones for this. Basically, one of the major problems in wind farm is fires, and fires will be caused by some sort of accident caused by maybe a strong wind leading to a broken turbine or something. So with our strong camera definition and our video linkage, we can be able to beam the video or the photos, and we can be able to magnify them and see what the problem is in this particular case. So we can be able to fix the turbines in a better way with better image quality. And of course, we know that the turbines are 280 feet high, and for someone to climb there to fix them or to take photos of what is happening, it's too dangerous for such a person. So with drones, they'll be able to help us fix that problem because they can rise above 200 or 100 meters above the ground. So in this case, we'll need a URLSC slice to be able to reduce latency or to be able to reduce the delay between the device and those receiving the data. And we also need an EMMB slice for high priority data for high bandwidth connection because we are streaming videos and photos which will need a high connection linkage. So for security and maintenance, we'll use drones for that. And then we need to use a sub-6 gigahertz frequency for the drones. Basically, this one will be enabling us to have a long distance autonomous beyond visual line of sight for these drones for us. We could use mmWaves, but they have low range. They cannot be useful in 100 meters above the ground or something close to that. So we are sticking with 6 gigahertz frequencies. And we're also implementing network slicing. So in this concept, slicing will allow multiple virtual networks to simultaneously run on top of a shared physical network infrastructure. So it will make a secure slice of aerial vehicle control independent of contact with payloads, such as videos and streaming to the ground. In this network slicing, like we are separating a single slice into 3 parts, in which we have a core slice, and we have a transport slice, and we have a radio access network slice. So the transport slice is connecting the radio access network slice and the core slice in the middle of that. And each of these slices has a controller separately working on each segment of the slice. So we have a major slice, and the slice is segmented into 3, and each segment is controlled separately from the other. And then in the next photo, we can see a photo. So on our drone, we are mounting a camera for video and for photo streaming. We also have a GPS module, which will enable us to track the drone wherever it is. Maybe if the drone failed somewhere 5 kilometers from wherever we are, we need to track it. So with our GPS, we can know where it is. We can also know where a drone is at a particular time to be able to navigate through traffic to avoid a collision of a drone with a drone, or a drone with a wind turbine or something close to that. We have Raspberry Pi sensors. So like we are measuring humidity, temperature, and such. So we need to embed smart devices on the drone itself too. And so with this solution, we can have the following applications. So like it will enable workers to be prepared for in advance for unpleasant scenarios like accidents, like fires, or a worker was being hurt during maintenance operations. And so also operations can be stopped when the weather forecast is not favorable. So with a drone, like a drone cannot maybe operate during bad weather. So that's one of the main problems we need to navigate. But during bad weather, we can be able to adjust our schedule depending on what we have. And we can use the drones with the sensors to know how the weather is likely to be tomorrow, and then we can be able to navigate with that. And then you can also have the temperature, pressure, and humidity to be predicted within the 24 hours using the data we collect using our drones. And of course, the data can be accessed remotely, like we have a cloud for that. And the drones is just enabling us to collect the data, and then we have to compute and implement the data in another place separately. And so drones basically are helping us to weather monitor the system, and we can use it as a mobile device because it can go where people cannot go. It can go in fire areas, like hot areas where there's accidents and such things, high altitude areas whereby a worker cannot be. So we think that's a good implementation for us. We also have a few references. We also used a data set. We could send them to you if you need them. I can also share the link to our slides, and you can be able to see them later. Thank you. If any questions.
Thank you so much for a great presentation. I would like to ask the challenge owner to give feedback and share comments and maybe ask questions from the group.
Yes, also here a short feedback. I liked the fact that you try to use the environment of the wind farm in order to improve the connectivity with the use of MIMO technology. Because I think that it could be a future possibility. And also another things that I like is the fact that you have tried to build a model in order to define what is the weather direction, what is the weather the best way in order to give a bigger efficiency system to the production. So it could be a use case. And then it's very nice to see this Raspberry Pi with all the sensor that is a cheap device that is on a drone that could go all around the park. That, for example, could be more than 5 kilometers, but around 5-10 kilometers, using this connection that collect all the data. For example, you can connect to the Raspberry Pi, in my opinion, also the smoke sensor. It's another possibility. All the sensors that you need to use, all the data that you have to collect, you can build on the Raspberry Pi at this point. And all the use case are very interesting. Okay.
Thank you.
Thank you, sir.
Thanks a lot to you.
I would like to thank everyone for good work and great presentation, as well the challenge owners for feedback. Soon, Professor Handelberg will give us closing credits of the course. So please stay tuned and see you soon. Thank you.
Hello guys. It has been amazing 2 weeks now, and we are almost all about finishing now. I hope you have learned a lot. I hope you have find some new friends. I hope you have find some ways to apply 5G. Maybe you have find or become interested in about 5G. That there could be opportunities for your further education and career as well. We are very keen on to continue to have touch with you after this course, because we look forward that there will be several practical 5G development projects starting already in fall. Some of them are carried out with the top companies from the developed countries, but also we look forward to start the first feasibility studies for smart campuses in some African cities already in fall. So keep in touch, enjoy the summer, and we see you, or we are in contact you again in fall. Thank you very much.
Thank you very much on our behalf as well. If you have any questions, you can send them to us via email, but the course is now over. You only have to send us your learning diaries, both regarding the mandatory lectures and your project work, and as well your project work slides. If you're international students, you send those via email, and if you have full access to my courses, then there's this place you can submit the slides to. Do we have something else to add?
We'll write you a wrap-up email about the course, and if there's something we want to mention, for example, about the certifications and so on, we'll write it there.
Yeah, so follow your emails, check what was sent, but thank you very much for the course, and thank you for your presentations. They were all very good.
Ainakin se sana